Nice, dude. I'm gonna present to this one guy. They're gonna want to close the doors, so you don't need to be here, okay? Yeah. Because they will need to open them close. Okay?
Evet, S.A. S.A. Şu an gelmiş olması lazım. Evet. Okey. Tamam, sen de dene, doğru. A. S. Gönderiyorum şu an sesi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A. S. A. Test deneme 1, 2, 3, 4, 5. Hey. A. S. A. A. S. A. Tamam.
Okay, right? Hello? Okay, yeah, it works. Hello. Okay, shit. Hello? Okay, 2 minutes. We got 2 minutes? Is it recording? Are we live? 2 minutes? All right. Nice. Nice. Perfect. It's good. Test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay.
Yani şöyle demek lazım. Nasıl bir duruş sergileyeceğimi bilmiyorum. Ona göre ayarlayacağım da.
Are you standing like this?
I'm standing. I'll stand like this. Can I do what?
Kendisi hala bir pozisyon bulamadı çünkü.
Hello.
İnşallah.
You want to use the microphone like that?
Yeah, I mean, yeah, I could. It's fine, right? This works. I mean, it's not bad.
Okay. Keep the same distance.
Okay.
Just to make it.
Yep. Got you. Yep. All right, we're live. What's up, guys? We're good? We're live? Okay, what's up, everyone? It's a pleasure to have you guys here. My name is Daniel. I am the head of integrations here at Unlimit Crypto. And I'm giving this presentation right now. It's a pleasure to have you guys. So, Unlimit. What is Unlimit? So, Unlimit.com started in 2009, started as a payments company. So, we're actually a team of 500 people. So, we're actually one of the few enterprise-size companies really at any of these hackathons. So, started in 2009 as a payments company. They got into banking as a service. A lot of the main business actually comes from working with, different e-com websites. Like you have like Telegram, like InDriver, which is like the second biggest app behind Uber and like LatAm. So our parent company powers a lot of these traditional payments companies, or it's a traditional payments company that powers a lot of different companies around the world. So we have, we have thousands of payment methods that can be used. We have multi-currency IBAN accounts facilitating international transfers, card transfers. We have card issuing, so we can actually issue cards. We have a BaaS, a banking as a service suite, and I am part of the Unlimit Crypto team, which started around last year, and our team consists of like 25, 30 people. So, Unlimit, right? So we are an on and off ramp. So Unlimit Crypto, we have an on and off ramp widget that users can use various payment methods that we have already established from the parent company, and you can essentially on ramp into crypto, right? So the question is, why? Like, why do we need another on and off ramp, right? We have a few died last cycle, but we still have a decent number. So the question is why, right? So I have to in order for this to make sense, I'm gonna take you through the progression of historically what on and off ramps were, right? So from the beginning, you had different companies, right? You had exchanges. That's really was the first way you could really on ramp was, so you have your Coinbases, your Krakens, your Bitstamps. They were one of the first people to allow you to ramp. And then from there, you had the introduction of various third-party integrations, which is the likes of MoonPay, Transact, Simplex. I actually worked at a company before this called Wire, which was like the biggest on-off ramp in the game at the time. And this progression, it was essentially a website, which was the exchanges, and then years later, now using these widgets, any company can integrate on and off ramps into their own app, creating a better user experience. But then the question is, how are they different, right? Really, the only way to differentiate between any of these on and off ramps up until now, up until Unlimit came about, was this on-ramp has, more cryptocurrencies you can choose from. This one has different payment methods you can choose from. Fees, right? So it's hard to differentiate in this game. There's only a few limited things that allow you to really be differentiated. So on the same note, differentiation. In order to understand how we're different and why, in my opinion, we're the superior on and off ramp in the game at the present moment, you have to understand how payments work. When you swipe your card at a store, or in this case, in our on-ramp payment gateway, what happens with your money? Where does it get routed to? Where do the fees come from? Why does any of this happen? How does any of this happen? So let's start off, right? You as the cardholder use a card given by your bank, which is known as the issuer, and the issuers are oftentimes called principal members, but I'll get into that later. So then you use your card, the store accepts your card payment through a point-of-sale system, but in the case of us, it's going to be a payment gateway, but it's the same concept. And the store has a bank relationship with an acquirer, and the acquirer ensures they can accept card payments, right? The point of sale system or the payment gateway connects to a processor. You have different players like FIS or Square, and the processor's role remains as the mediator to ensure a smooth conversation between the store, the network, and your bank. From there, the processor informs the acquirer about the transaction details. The acquirer at that point facilitates the transaction by connecting with the network, for example, Visa or MasterCard, and asks if the card is valid and has enough funds. Visa then speaks to the bank that issued your card, which is the issuer, and then the issuer checks if there's enough money and sends back a message either approving or declining the transaction. The processor transmits this message back to the store's system. If it's approved, the money eventually transfers from your bank to the store's bank. As you see, it's kind of complex. There's a lot of players in the game. You know, you have multiple companies from the point you swipe to the point the actual transaction is finalized. There are multiple companies touching your funds and moving money around, communicating with different networks, and that's traditionally how it works. So then the question is, okay, how are we different? So that leads me to my next point, which is what I stated earlier. Unlimit started as a payments company. We are a banking as a service. We have an EMI, which is an electronic money institution. We are able to issue cards. As I talked about earlier, we're a principal member of Visa and MasterCard, meaning we have the ability to issue cards. The other people who are principal members are the likes of like JP Morgan, major banks. So a lot of the major banks have the same ability as we do. So what does this mean? So your traditional on-ramps, all they are is they're just gluing together a bunch of APIs. They don't really own any part of the stack. So what that means is they're just gluing together a bunch of third parties. Their fees along the way, every step of the way. Not only fees, but you're exposed to FX spreads. So essentially, because of all of these things, you're not getting the best rates. That's why if you use like a traditional widget, you put in a $100 order, it says, okay, here's $91. So you're getting the fee is insane. It's like a 10% fee right now, which is kind of absurd. So how are we different? Unlimit is the acquirer, we are the processor. We essentially own the entire payment stack, meaning the likes of MoonPay, Transact, right, Ramp, all these other players. When you make that purchase, they're routing your order to the likes of Checkout.com, who's an acquirer, WorldPay, who's an acquirer, different processors. So they don't own the stack. They're letting other people do it, which means everyone's taking fees along the way. So by the time the transaction is finalized, boom, 10% is gone. With us, on the other hand, we own the full stack. Therefore, we can essentially minimize the costs more than anyone else by a significant amount. So for example, go to onramper.com. They're an on-ramp aggregator. Really, 90% of the quotes we're winning right now because of this reason, because we own the stack. So then the next slide. So essentially we're a global company. So we're based in actually London and Cyprus. And when this company started in 2009, as I said earlier, it was based in Europe. So we're very specialized in Europe, LATAM, and APAC. And traditionally, you know, the likes of like the major on-ramps, they're really focused, a lot of them are based in the US. And while they do have, you know, various payment methods globally, like SEPA or like SPAY, they don't have very localized payment methods, right? So in the on-ramp game right now, you can use either the major ones or you can use other on-ramp providers that are smaller, but they provide you with like a very localized payment method. So for example, in Mexico, bodegas are actually huge. So in Mexico, we can actually allow the users to go to a Walmart, pay with cash, and we give them crypto. That only exists there's a few very small on-ramps that have these localized payment methods, but they don't have anything else. So there's no on-ramp currently except us that allows users to have all the major payment methods, also as well as the very local payment methods. And Walmart was one example, but in Mexico or Brazil or in Asia, really it's, we have hundreds of different localized ways you can go about to stores, do cash vouchers. There's a bunch of ways you could essentially on-ramp into crypto, which didn't exist before. And this all came about because this company made in '09 took their stack. They realized, hey, we have this crazy stack no one else has. Let's actually integrate crypto into it. So unlike every other company that's in this on-ramp, off-ramp game, they all started as crypto companies. We started as a payments and banking company and realized, hey, we can outcompete everyone here because we were essentially didn't start as a crypto company. So with that being said, this essentially leads me, everything I just said leads to this slide, right? So what is the next generation of on and off ramps, right? As I said before, I actually worked at Wire. They unfortunately went out of business, but each of them came in with very incremental improvements, very small incremental improvements, right? So for example, you had Simplex. They were actually like one of the first, they were the first on-ramp widget, essentially, that could integrate into other people's software. And they came about, and they're really good at cracking down and making sure, like, hey, like fraudulent orders, we're gonna crack down on that, right? Then you had the likes of Wire come in, right? They realized, hey, Simplex has this widget, we could do that too, but let's actually create a white label APIs. Let's actually take all the functionality within this widget and create APIs so any developer can make anything with it. And unfortunately, up to today, the Wire was the only one who had that. No one else has that. Even we don't have the APIs yet, but you had other people like Prime Trust, right? They actually went out of business. MoonPay actually focused purely on the widget and made incremental improvements. Sardine was the one, they actually were a fraud company. So they actually were really good at taking the data they had from all of these orders that were getting blocked, and they created a really good fraud engine. They realized, hey, we could take this engine, plug it into crypto. So essentially very, very small improvements to the user experience. But for us, we essentially own the hardest part. Essentially, this on and off ramp game is not a technology game, right? It's purely regulation, who owns licenses, who has connections, who can work in this country, who can work in that country. That's really the blocker. It's not the technology. The technology, anyone here can really make. It's essentially shaking hands and getting regulated and getting the stamp that, okay, I can operate here, I can have this payment method, I can do this. That's the hard part. And that essentially is what creates the fee. That's essentially the end user who gets the most crypto. That's what it's relying upon. But no other players in the game own the stack, right? As I said earlier. So Gen 2 was incremental improvements. In my opinion, Gen 3, which is unlimited crypto, we own the stack. Your fees are lower. You're exposed to less third-party risk. You can work with us directly, right? So, for example, at any of these, like Wire, for example, right? Because we didn't own the stack, when you got someone, an end user didn't get their crypto or something went wrong in the payment, and we didn't own it, so we had to reach out to, checkout.com or WorldPay or this person, and it took them a week to give us an answer. That's not cool. But for us, since we own the stack, I just go directly to my team. We figure it out in 10 seconds. So the entire experience is just significantly better because we own the full stack of the payment layer. So what does this mean, right? So I explained to you why this matters. And I think explaining to you why this matters is very important because there's all these on-ramps, but like what's the difference? Fundamentally, this is the difference. So for the sake of this hackathon, we are going to be using account abstraction with our on-ramps. So you as a developer, figure out interesting ways to take ERC-4327 account abstraction, combine that with our on-ramp, and create some novel experiences that don't exist currently. This picture is showing a bunch of cowboys looking at this chest because no one really has made the killer dApp that doesn't exist yet, right? Everyone's building it right now, and it's the race to build the killer dApp that wins the market. So we have the infrastructure, but there's no really good at all consumer apps that take full advantage of all the functionalities that AA offers. So what is account abstraction? So what is account abstraction? Let me get to this slide real quick. So conventionally, your MetaMask, or the crypto wallets you've had before up to this point, they're called externally owned accounts. And they have their own validation logic hard-coded into the blockchain protocol itself. For example, Ethereum has specific rules, like the gas fees must be paid in ETH, nonces must be sequential, very specific rules that can't be changed. And in contrast, account abstraction wallets, right, like account abstraction is not a brand new concept. It's been around for years now, in theory, but ERC 4337, creating a standardized version of it, that's really the new thing. But the actual functionalities has always been around as smart contract wallets, right? Smart contract wallets can program their own custom validation logic via smart contracts. So for example, you could have rules like require two-factor authentication in standard transactions, batch your transactions, pay gas in whatever coin or token you want. And if developers publish a new standard for the smart contract, users can update the logic for their smart contract wallets by pointing to the contract. So essentially, super customizable. And not only that, but it's a smart contract. In theory, your wallet now can become a dApp. No longer do you need to go to Uniswap, to some NFT marketplace. You can essentially just code that within the wallet itself. So to the point where you open your wallet, you have Uniswap, you have everything within there. So that's a thing right there. And yeah, so I said that. So here's some interesting features from account abstraction. You have the ability to sponsor gas, the ability to batch transactions, the ability to have session keys. Users can authorize temporary keys with specific permissions to do X function that is predefined. You have social recovery. So if you lose your keys, you can actually have a recovery, a guardian as it's named, to help you recover the wallet. As I said, upgradable validation rules. You can pay in gas and other tokens and coins. And in my opinion, the most interesting thing is the ability to add plugins. And these plugins are essentially code within your wallet that allows the user to do really anything now. I mean, any literally smart contract code can be plugged into your wallet to allow for XYZ features that couldn't have been possible before. So here are some concepts that are now possible with account abstraction. So you can schedule future transactions like subscriptions. Use it where if you're trading, if you're about to be liquidated, you create rules saying, hey, if the price hits X point, send crypto to this wallet to fund the account. When games release NFTs, your wallet can be programmed to automatically purchase it. So essentially, creating automation, right? Like for end users who heard about staking, but they just heard about crypto, they want to go to Curve, they want to stake. It's kind of insane. It's really hard to do for a new user to go through all that. Theoretically now with this, you can essentially allow an end user to on-ramp into a wallet. Once the crypto lands in this wallet, your logic and smart contracts can say, hey, take the crypto, go to Curve, do X, Y, and Z, stake. When after a week or two or whatever time frame, send it, unstake, send it back. Essentially, that could be written in the wallet itself now. So users don't even need to know what Curve or any of these websites are. They can just on-ramp into a wallet, that's abstracted away, they don't worry about it, and they get the benefits from essentially doing this. So what does this mean? It's a question. I mean, let's go back. So what does this mean? I mean, essentially, end users who are new, right? I'm sure a lot of you guys are crypto native, and you've been playing in the game, going here, going to this dApp, experimenting around. It's hard, right? For a new user who has no idea what crypto is, they're not going to do that. They can't do that. They barely know how to use a wallet. So how do you expect them to stake? How do you expect them to do X, Y, and Z? They can't. It's not a real expectation you can have for them. So now all of the functions and features and things crypto natives have been doing that are amazing and make crypto fun and cool and everything and solve all the problems that crypto is trying to solve, end users who have never touched crypto can now do that. You guys can create the experience that simplifies it to the point where they don't even need to know anything happening. They can just on-ramp and boom, they have exactly what they want. I'll get to the questions at the very end. So, oh, 1 minute? Oh, I'm sorry, I thought you were the end. That's good. Okay, so after this, we have a Telegram channel. We have a table over there. You can come by our table. I have this demo, which actually we use ZeroDev, but you guys can use any account abstraction integration you want. And this is a full dApp that actually works. So if I go here, this is what our dApp looks like, right? So it has actually the wallet. It has everything integrated. You can clone this, and you can make whatever you want out of it. Here is our widget. It's in Spanish right now because it's a param. So we have different variations of how you can go about it. We have APIs. So the idea is use our on-ramp, combine it with an account abstraction wallet, and essentially do something novel within the Web3 space that has been conventionally easy to do for crypto natives, but very difficult for people who have no idea what any of this stuff is. So with that being said, we have our API docs. Here's my Telegram. Reach out to me. Come join our hackathon. Let's have a good time. Done. Nice. Cool. That's it. Let's go take that. Yeah, for sure. No, for sure, man. I thought you were questioning, man. I thought you had a question. My bad.
We should have one. Yeah. We have one here. There you go.
So where to connect?
Yeah. Okay. So yeah, go ahead. So well, you know, I try and do that. You know, Awesome. Yeah. Okay. I think you need this cable.
Mm-hmm. Thank you. Yeah. Very nice. Oops. Yeah. Hello, everyone. I saw a few familiar faces as well. How's your week in Istanbul? Great. Yeah, I personally I love those meat and dessert. Oh my God, that was killing me, you know. So nice to meet you all. So I'm Wei Duan from Mask Network. Also, we're working a open source DID protocol named NextID. That is what I'm gonna presenting to all of you guys. So today my topic is tech reputation anywhere with DIDs and universal profiles. And this is me. So Wei Duan, you can find me on Twitter, BinaryHB. Unfortunately, our CTO couldn't catch it, so he's also an initiator for this project. And yeah, he's around. I hope he can see you in later times. And today's agenda will be like dividing into 3 parts. So let me walk you through like the identity past, present, and the cyber future, where I will discuss you with the thoughts on why we want to take on this project, and our thoughts on what is identifier and what is powerful identities, what shape powerful identities from those centralized identities in the past. And also, we plan to launch a supercharged UX with a sovereignty identity as well. So first, identity in the past, you can see, so this is a typical identity card we all get. This is a driver license in the United States, Coronado State. You can see you will have your IDs and your faces, serial numbers assigned by this institution. So it's credentials and it's certificated by institutions, and governments issue passports, credit institutions aggregate information, but all of these are under black boxes, right? If somebody in the government, they hate you, or I don't know, they maybe have like interest confliction with you, they may like delete your file. So that happens as well. So like Web2 identifier nowadays, right now we are a digital user in the internet. So apart from driver license, you are getting your emails, phone numbers. By using these identifiers, you will be able to get right on airplanes. You have get token gated orderings, and you get your mortgages by your identities. And we're kind of in this, progress life into like cyberspace, like digitalized our full life. So you can see from the global market, people are spending at least 80% time online, and this keep growing and growing. And the question lies, how can people construct digital selves in the future? What defines you and how you use IDs? Apart from the past experiences, we have IDs, identity card from the government or central institutions. And here we come, we are ending the Web3 era, so we have a Web3 identifiers today, and we want to propose this question, is wallet really identity? So this is the question that intrigued us to want to take on the DID track. So we thought a wallet, they are specific to ecosystems, like chains, like ecosystems specifically. So they are only like identifier. They cannot representing you. And also we do think you can't use your like bank account. Let's make a metaphor here, because in Web2, you have an identity card, then you have a bank account all there in like different banks, right? So you wouldn't call your identity equals to those bank cards. So we need to logically classify these two are two different things. Yeah, so by speaking of all this, so we needed to combining all those Web2 identifiers, Web3 identifiers, and also the data histories on Web3. That's where we are having this idea. So in Next ID, we want to issue yourself with a key pair. We call it avatar, just like Rose EOA wallet did, right? You have a public private key pair, then it's a self-issued on decentralized storage infrastructure. Right now it's on RF, I will show later. Then it's a chain agnostic. We're just software, so you wouldn't, we wouldn't limit it in any kind of specific chain. Then by doing so, you will have your own entity. And then after you have your identity, So we brought up a new idea called identity graph, so that you are linking your identity with all those Web 2 identifiers, Web 3 identifiers, all the identifiers out there. Then you have the histories of who you are. And again, we think identity now equals to wallet. And get rid of this, the text is kind of abstractional. So let me show you what we're doing. So 3 services we're having right now: Proof service, relation service, and core services. Proof service is where you get your identity created and do the authentication kind of stuff. Then relation service will be the open social graph. This is the part we feel in favor of. We also wanted you hacks to build upon it. And it's an upcoming core service is a private cloud controlled DID. So it's still in a very primitive stage, but we were heading there. Then the first identity creation and authentication is done by the proof service. And this is the picture of that. So you can see in the center is the avatar. So it's a generate public private key pair. Then you use this avatar binding with your Web 2 social platforms as Twitter, also Facebook. So how will we do that? So like it's a 2-dimensional cryptographic binding. Like you are the user, you are a user on Twitter, right? So you have an account to tweet. Then your tweet, you post a tweet. Inside the tweet, you will have your one signed message, which is signed by your private key in your avatar. So like both dimensionally, you proves you own the Twitter account. Also, you have the private key of that avatar. So, boom, those two are binding together. But it's a core for users. You decided to do that. Meanwhile, it means you're somehow leaking your information on the internet. So it's a tough call. Just be cautious, be aware of that. And we do where this kind of problem also cause hesitations from the users, but we will need this to the JK tags in the future. Then after those Web 2 IDs banded, you can also bind it with your Web 3 IDs, like your smart contract wallet, like all those wallet address on blockchain. This is the tech infrastructure, because you are all hackers. Just get to understand that I mentioned before, we store all this mapping, like binding informations on our wave, so nobody can change it. It's just the public infrastructure. But we do offering APIs on AWS. Let's make it much faster. But you can like pull up your API service based on our open source protocol as well. So this is basically an easier way to understand the tech architecture. Then here comes the great part, open social and identity graph. So for instance, right now, I think this argument in the industry was how we're gonna, identify or prove you are a real person, right? So it's kind of problem industry facing, and there were 2 major approaches to want to solve this. The first is like WorldCoin type of wise kind of solution. They want to scan your eyeballs or your fingerprints, those kind of biological prints of yourself. They are unique, but we do endure the risk of if we nick it out. That's kind of terrible, right? If imagine you have an eyeball installed in a machine robot who can completely represent you. So your risk, everything you have on the internet are in great danger. So we don't certainly we don't prove that. So that's why we are posing another solution, which is called open social identity. Like today, all of us are sitting here in this room. So right now, I have like NFT poll apps. We can integrate with each other. We can swap cards with each other. So we'll left messages or histories on chain that can prove something. And all this data is aimed up that it can prove somehow you are not a robot because you have a real interaction with other people on the history. So that is kind of look like this. So a social graph, the white circle one represents one of your identities. And the scalable data framework because it's open source, so wanted you to use it. So let me give you a just quick live demo on Web3.bio so that I get to understand what it is. Web3.bio is that interface we built for you for presenting to get you to understand what relation service can do. So Web3.bio, then you enter this. You can search anything you want. Like right now, I'm typing in the founder of and CEO of Moscow Network. He's in this domain. It pops out with all the information linked within. So see, these are all the ENS domains he has been using, and he bind it with the space ID, forecast, lenspo file, and with the bridging of next ID avatar. So it bind it with your Twitter, your Discord, your Reddit, GitHub, Discord ID, all of that, right? Again, you may concern, this kind of make privacies as well. We do concern as well. So this is a problem with still we're trying to solve. But after you're doing this, it's much easier for projects to identify who this guy is, like through one of the addresses. Because most of the projects are confused. I don't want to airdrop to Rose boss, right? I do want to airdrop to Rose real users to be a stable attack distance. So this could be one solution for that. And many other scenarios as well. And let's go back to the slide. Then the universal profile API is that we build up upon relation APIs because a relation service is built under a graph database. So you can query the data via GraphQL, which is not that so much friendly. So we build an API, RESTful standard format APIs for you easier to use. So you can access the API, the web3.bio. This is the site. To access the endpoints with the parameters to adjust using this to fetch data on this open social graph. And this is the partner corrections as HN3, the .beats or the 3. Mask, of course, our model company, like data platforms as 0xscope, XMPP, Clubland, blah, blah. And this page showing you like the former ETHGlobal prerequisites. So like the team data for builders, some of the teams are here as well. They win their graph IDs. They are doing relation service with identity graph. Also social capabilities, pro service, the project Builders Garden. And our recent winners on ETHGlobal New York. With Telegram bot integration and also SocialFi kind of stuff. And right now we are in Istanbul, so 10,000 USD event as well. Just try it out. We have 3 parts. The first is about fully on-chain gaming. Fully on-chain gaming is also a certain area to utilizing DID. So we do want to invite hackers together to design this on-chain gaming game account solution. Then the second part will be the best use of Nix IDs. Mainly just use the universal profile API relation service that we do it. Then unveil your revolutionary social app. This is for a Moscow network. So we are a favor of decentralized social. Yeah. Thank you. That's me. Please do follow us on Twitter, next.id, and join our Telegram group. If integrating an API, you're getting any problems, issues you want to ask, just feel free to post question in the group. And you can find us also in GitHub, of course, fully open source project, GitHub, next.id, and next.id, the domain, which is easier to access. There it is. Great. I think that will be my 2 minutes early. Thank you all.
So, 2 things. We are very very tight on schedule, so try to
Yeah.
keep it under 20 minutes. Or
I'll keep it.
if you feel or to leave some room for questions, just the thing is, when I will sit here, you'll have 2 more minutes.
Yeah. Should this be coming up there?
Yeah, it should come. Let's see.
Yeah, sometimes with Linux you have some. Maybe I can try the other side.
Yeah, try the other side, maybe.
Sometimes it's like that.
All good.
There we go.
Well, let's see if that thing starts. Yeah.
All right. I'll change the color. People always complain about me having an orange screen.
And if at the end someone has a question, please repeat it in the microphone so people at home hear it as well.
Yeah, this is being live streamed, by the way. That's why we need.
Yeah, totally.
Have fun, Greg.
Thanks. Well, yeah, since we're tight on time, I'm just going to get started. Are we recording? Okay, hi. My name is Grant. I work on a project called Phi. It's a language. It's a Rust-like language that the compiler is implemented in Rust and it targets EVM. I work at the Ethereum Foundation, and there's 3 others on the team. So basically in this short amount of time, I want to introduce you to the language and help you find useful resources. So, oh, dang it, it's not displaying my, why is that not? Okay, hold on, I gotta fix my display settings. Okay. There we go. Okay. Can you guys read that? Can you guys read that? No? Okay, well. Okay. Hold on here. Basically, this is, if you want to take a picture, I've written this up just in the minutes before. This is like all of the stuff that I'll be covering. So if you want to learn about a language, you can go to philang.org. There you'll find these top right tabs. You'll find a link to our Discord, and under Learn, you'll find our documentation. So a lot of the stuff I'll be covering is here. Also, you can find the binary for the latest version on the front page. So to get started, you can just download that. But yeah, I highly recommend taking a picture of this if you're interested in working on Phi. We're offering 5K in prizes. Those are bounties for you to simply implement something in Phi. Considering the features that we support, you might find yourself in an advantage using our language, and you could, maybe cash out pretty good here. Yeah, so I will just demonstrate the compiler real quick. So typically you'd go through here, you download it, and then you put it on your system path or whatever. But for the sake of this, I'll just have the binary in my in the directory that I'm working in, and we'll do that. Okay, so this is what it looks like when you execute the binary. You get the types of commands that you would expect to find in a binary, in a compiler CLI. Build, that's for building your project, building the contract artifacts. Check, that's for performing analysis. So if you're just interested in the type checking results. New for creating a new project. Test for testing your project. We provide a built-in test runner built on top of our EVM. That's the same test runner that Foundry uses, but we just distribute it with the CLI. And then we recently added this verification stuff for on-chain verification. If you want to create a project with some boilerplate code in there, you can just run the CLI, new, come up with a name. You don't need those. Do my project. Okay, so now I've got a new project. Quickly go over the directory structure here. So if you're familiar with Rust, you'll know that there is a TOML file in the root of your project directory. That is the manifest of your project. So that describes what the project is. So it gives a name, a version, and also dependencies. So we support file system dependencies. At some point we'll add like a package manager and stuff, but if you want to add some sort of library or something, you can add that under your dependencies and it'll just compile right into the project. It's a pretty advanced system. We support circular dependencies. Basically, we're using the basis of the Rust analyzer, which isn't even being used in the Rust C compiler. So yeah, that'll all work pretty well. We support structs, enums with pattern matching. We support generics. So yeah, let me just get into it. So now we have this project. Let's take a look at the source directory. Now what you'll see here is we're importing a module, utils, here. This utils provides, oh, you can't see this at all. I'm sorry. Okay, well that's good enough. Yeah, you guys couldn't even see the CLI stuff either, that's too bad. Okay, what time is it? I've still got time. Yeah, so here's just a simple utils module. You know, you can imagine you're working on a project, you don't want to stuff everything in one file. It seems like the standard for a lot of development in this ecosystem is you just copy and paste things into a file. That's not really acceptable here. So yeah, say you want to put something in utils, you can write your utility functions. You could create your utility structs, enums, traits, whatever you want, and define them as public. So if you want something to be exported from a module, you need to define it as public. You can also write tests inside of a module and execute those with the test subcommand. In the main file in this project, we've just generated this main contract, which just exposes a get42 function. So contracts and fee are pretty similar to Solidity contracts. This is not like a design that we're committing to long term, but people are just used to this contract design, so we've just implemented it in a very similar way to Solidity. At some point we would like to provide alternatives, but you know, right now we're just sticking with this because it's easy and there's really not a whole lot of downsides to it. So yeah, public functions conform to the same encoding decoding that you'll find in Solidity contracts. And yeah, so basically what we have here is we have this public function being exposed on the contract, which can be called, and we're just using this get42 util function. In the util file, it's called get42, but we support, you know, renaming things, which is kind of nice. Yeah, so now we'll just we'll go ahead and do some testing. Okay, so as you can see, both of these tests are passing. So in this test main, what we're doing is we're creating a contract. Now we're using this context type to create the contract, and that's defined in the standard library. We're not importing it because it's included in the prelude, but if you wanted to see exactly how context works, you can go to our repository, you can look in the crates library folder, and you'll find the standard library definitions. Yeah. Also, you can see we have explicit mutability semantics, which is very nice. It can really help you with writing code that behaves in a predictable way. We have some compiler magic taking place right here. Context is also treated like a special object in certain cases. Basically, we have this create function, which is defined on contract types, and you can call it. You just have to pass an immutable instance of context. Yeah, in order for us to have a full language implementation of contract creation, we're going to need a more advanced type system. So this is just one of those cases where in order to provide a palatable user experience, we need to build something into the compiler. But in this test, what we're doing is we are creating an instance, or we're deploying an instance of this main contract, and then we're calling it. Yeah, so now let me just show you what happens if we break something. There are some downsides to the test runner. Basically, when something reverts, we just spit out the revert message. So that's going to be the same encoding format of the error message that Solidity uses, but we just haven't gotten around to decoding of things. If you wanted to say, debug your program, you can create an event. And I won't get too much into the specifics here, but everything that I'm doing here is explained in the documentation. And I'll also just introduce maybe a few errors to demonstrate what, here, I'll just make this the wrong type, and then we'll see what the, nope. I put that in the wrong one, sorry. I meant to do that in the main.phi test. So let me just move this over real quick. Okay, now we should get a compiler message here. Can you guys still see that? Looks like it's fine. Yeah, so we have something that's really important in general when you're designing a language is to provide error messages that can be easily understood, and that's a high priority of ours. Yeah, so pretty straightforward explanation as to what we're supposed to do here. Bool is used here as a value, but it expects a U256. Oh, sorry. Kind of on autopilot here. Yeah, it expected bool. It expected type U256, but it got a bool. Yeah. Okay, so we'll fix that error, and then we'll look at the. We'll run it. So it's saying the test has failed again. Let me just quick fix that so we can get that noise out of there. This is something in the last hackathon that people, this is something in the hackathon that we were at last, people asked for, basically just being able to debug tests, and something that we added. I didn't save this, unfortunately. There we go. So we're not seeing that event yet. In order to do that, we need to pass in the logs flag. So we'll decode the logs for you here. So if you end up using phi in your project, this is just a helpful thing that you might want to look into. Yeah, let's see, 9 minutes left. So, oops. Yeah, so we're getting this nice syntax highlighting in VS Code. This makes it a lot easier to see what you're doing. If you want this as well, you're going to need to get the phi VS Code extension. And what we have a few VS Code extensions out there because we've had a few different developers create them. But as of right now, there's only one that's working, and that's the one that's created by phi-lang developers and is on version 0.02. So yeah, if you want to get this, you can just download the extension, but make sure you get the right one. Again, that's phi-lang developers. All right, let's see if there's anything else that I wanted to go over. Yeah, so let me just reiterate again, we have 3 prizes. It's all split between 5K. So yeah, we're just asking that you use phi in your project. Or you could, just target phi. And yeah, maybe since we support libraries, you could write something like a cryptography library. You could maybe implement a memory map type, things that are generally useful. These are the kinds of things that we would really like to see as hackathon submissions. But if you just feel like using phi for like an application, that's definitely something that we'll consider too. Yeah, and if you, is anyone here familiar with the MD book documentation format? Yeah, so it's really nice. This is, something that Rust has popularized. Say you want to look into deploying a phi project with Foundry. You can just go to our documentation, search Foundry. You'll find a quick start guide. You can also write tests, in Foundry on contracts, so you can reuse a lot of that tooling here. The test runner that we support that's built into the compiler, that doesn't really have anything to do with this. This is just a separate thing. But since so many people are familiar with Foundry, we've made sure to integrate with their existing tooling. Yeah, and then if you find yourself really deep in the weeds and the documentation is not helping you with your project, you can go to our repository if it loads. And go into this crates directory. Here you can find the standard library implementation. You can also find a whole suite of tests. mostly testing the standard library. So you can find like use of precompiles in Phi. Obviously precompiles, and you can't see any of this, I keep forgetting. Let me zoom it. Let me zoom in. Yeah, so say you want to see how you'll work with any of the precompiles, you can just go into our test directory, crates test directory, and you can find usages of all the precompiles. Here's the use of EC recover. We have labeled parameters. So yeah, anytime you want to call a function, if it requires that you label parameters, then you have to do that. It ends up making the code look a lot more readable, especially when you're dealing with like a function like send a value or something, where you just have all these random parameters. I, for one, can never remember what order they're in, what anything means. So like, just having the compiler check to make sure that you're passing in the parameter that you expect is really nice. Well, yeah, does anyone have any questions?
How can I interact with Solidity existing contracts?
Yeah, so, we conform to the Solidity ABI. There are distinctions between the Solidity type system and the Phi type system. Ultimately, we would like to have a library that provides full support for interacting with Solidity contracts. But as of right now, you'll find limitations when it comes to like dynamically sized things. I know there are workarounds. You can figure out solutions to things, but generally, like, statically sized things work totally fine. And then, yeah, there can be some issues with dynamically sized things. In Phi, you can define a call function, which you can find if you were to search. Are you familiar with like the underscore syntax in Python, where it's like underscore underscore like that? That's the syntax for both constructor and this call function, because they're kind of like these special case functions which you can define in a contract. So right, like the underscore init function allows you to define the initialization of the contract, and then the call function allows you to define the call handler for the function. So say you just want to totally bypass the Solidity, the contract ABI that Solidity uses, you can just write a call function, you can define a call data reader, and then you can just decode against that call data reader however you want. So, if you were to write a function that is, if you absolutely needed to write something that handled a dynamically sized data, you can do it that way.
Is there any language server protocol implementation now?
Are there what?
Language server protocols,
Yeah, so we're working on one, but it's dependent on a refactor. Sorry, we're working on one, but it's dependent on a refactor of the front end. But yeah, we do have someone that is dedicating half time to it, and it's very good progress. So we hope to roll that out in the next 3 months to 6 months.
What functionality does the VS Code plugin have? Only syntax highlighting or something?
Only syntax highlighting, that's correct. Yeah, he's asking about language server protocol. We're working on one. Currently, the VS Code plugin just supports syntax highlighting. Slightly higher, I'd say. Yeah. But again, yeah, he's asking where does the gas consumption sit? Slightly higher. But so in our standard library, we provide an EVM module, which provides direct access to all of the opcodes that are provided in UL. So if you want to write something that's pretty close to assembly, you can just do that. The higher level abstractions, since we're kind of a younger language, haven't been fully smoothed out, so there might be some inefficiency there. Yeah, so one more question if anyone has one.
How can I interact with contracts from frontend? Can I generate API or like in Solidity communicate with contract from frontend from JavaScript?
Well, yeah, I mean, I would recommend, okay, so he's asking how can you interact with the Phi contract. Yeah, so we generate a JSON ABI, right? And again, we've kind of like hooked into some existing Solidity Foundry tooling. So I would recommend using Foundry for something like that. And you just, you won't have any issues because we conform to the same contract model as Solidity. All right, thank you very much.
HDMI? Let's see if this works. All right, cool. Well, hello everyone. My name is Diego Ferrer, and I'm a solutions engineer at Celestia Labs. And today I'm going to talk about how you can deploy rollups with modular DA in minutes, right? Before we get started, let's just quickly go over the agenda, like what's Celestia, what type of rollups do we support, what's Rollkit, like how can you use Rollkit with Polaris, and also go a little bit like in detail about our Celestia OP Stack integration and our Arbitrum Nitro integration. So what's Celestia? One of the co-founders of Celestia, Mustafa, recently had a tweet that said, Celestia is a modular data availability network that securely scales with a number of users, making it easy for everyone to launch their own blockchain. So let's try to go a little bit deeper into like what each of those aspects actually means. So modular. Celestia is a modular blockchain because modular blockchains decouple the core functions of a blockchain, which are execution, settlement, consensus, and data availability. So over here is like a nice quick little diagram that kind of showcases what it means to be modular. So if you think about chains like Solana or even Ethereum, they're monolithic chains because they fulfill all the functions of a blockchain in a single layer, right? Execution, settlement, consensus, and data availability, where Celestia only focuses on consensus and data availability and delegates the job of settlement and execution to other parties, which in this case is rollups. How is data availability related to scaling? Well, with data availability, or more specifically, data availability sampling, like clients, such as the ones that we have in Celestia, users with the lowest hardware requirements are able to still verify the data availability of the chain without having to fully download a block of data, meaning that end user verifiability has really low hardware requirements for users across the network. The more demand there is of like Celestia block space, the more people are running like clients, the more people are sampling blocks, and the more people we have sampling blocks, the safer it is to essentially make blocks bigger on Celestia without sacrificing the hardware requirements to run a light node, right? So if you think about that compared to a chain like Ethereum or even more prevalent something like Solana, verifying the chain means like running really, really beefy hardware, right? It's a common relationship that we know. Like if you look at the history of blockchains, if you want bigger blocks, meaning more space, more scalability, you usually increase the cost of like being able to verify the chain. But when you have data availability sampling like clients, verifying the chain cost dramatically decrease. And yeah. Now, what does it mean to launch your own blockchain, right? So Celestia, again, only does data availability. We don't do settlement. We don't do execution. So there's really a lot of different flavors of sort of like rollups and stuff that you can build with Celestia. We're mainly going to talk about sovereign rollups and just Celestiums or Ethereum rollups that use Celestia for data availability. So what are sovereign rollups? You may or may not have heard of what they are before, but essentially a sovereign rollup takes care of both its own execution, but also its own settlement. So it's a self-settling blockchain or self-settling rollup, and it delegates consensus and data availability to another blockchain such as Celestia. Compared to a traditional smart contract rollup where, we're all familiar with kind of how they work, right? They post data to a chain like Ethereum, and in that same chain, they settle through a smart contract and either handle disputes for a optimistic rollup or validity proofs for a secret rollup. A sovereign rollup doesn't have a smart contract to talk to, since Celestia doesn't have smart contracts, but instead the verification of the validity of the state of the rollup is performed through proofs like fraud proofs or validity proofs that are relayed peer-to-peer. How can you build a sovereign rollup? So at Celestia, we some of the folks created a public good library called Rollkit that allows you to build sovereign rollups using the Cosmos SDK. And more recently, we integrated the Rollkit library with a framework called Polaris from the Berachain folks, which allows you to build EVM blockchains. And by combining Rollkit with Polaris, we're able to run sovereign EVM rollups. So how does that work? That documentation PR is actually already merged to main. So if you just go to Rollkit dev, you'll be able to go to the docs and see what is Polaris? How can I use Polaris? But essentially, it's very simple. You clone the repo, you install Foundry, start the rollup, and you're done. So as an example, let's see if I can. Let's see. So I have that right here. I already have the dependencies installed and whatnot. I am going to need to start a local that, right? So we run that. Oh, I don't know why it's messed up, man. All right, now it's running. So now we have a local Celestia container, right? So that way you can easily sort of debug stuff. You don't have to worry about spending testnet tokens or mainnet tokens at the beginning, right? Obviously you want to hit testnet or mainnet at some point, but ideally you can iterate and try things faster by running things locally. Once you have that running, you can, for example, after you've already cloned Polaris and you have all the dependencies, right, you can do make start, and that will start the chain. Sorry, it's also a little bit hard to see with the projector on the wall, but it may or may not take a little bit of time, but if anything, we can just get back to it after I talk about the other rollups that you can build with Celestia. So let's see if I can do just that while this runs. So we'll get back to that in a second, right? Let's talk about building Ethereum rollups, right? Or more specifically, how you can build L2s, L3s, and beyond, right, with Celestia DA, and why would you do this, right? So running your own rollup on Ethereum has a big problem, and that's the fact that publishing the call data for your rollup on Ethereum is really expensive. Here's a screenshot I took of Dune dashboard this year. These are all the cost of different L2s on Ethereum and how much they had to pay for call data, right? And this is during 2023, which obviously had less demand for this block space than during the bull run, meaning it's not congested and it's still very expensive. It's a very scarce resource. So the solution to that is to have your rollup post data to Celestia. Why would you do that? It has great security, it has significantly cheaper price, and it's also built for you. It's a modular DA layer because it serves the purposes of serving DA for rollup builders such as yourself. Here's an example of the folks at Upnode that are currently running a 2048 game on an OP Stack Celestia chain, and where it shows how much it costs to execute a transaction, right? Here I also have some math that I pulled out from our docs on how you can estimate these costs, right? Because I'm about to show you how cheap it is to post your data to Celestia. So I use these calculations at another presentation, but essentially Polygon CKVM published half a gig of data at a cost of $153,000, right? The past month, or $300 per megabyte. With Celestia DA at the price of $5 per TIA, that's $4.22 per megabyte, which would have costed Polygon CKVM only $2,000 in D8 costs, right? And now, let me get my mouse over here and I can show you. Sorry, it took some time, but that is our sovereign EVM rollup running on Polaris, right? So that's communicating to our local Celestia testnet. The way that works is essentially you're running this Cosmos SDK chain that replaces Tendermint with the Rollkit library, so it converts your Cosmos SDK application into a sovereign rollup. And that plugs into Polaris, giving you EVM access, right? So you have access to all the tools that you're probably already going to use during this hackathon. You can use Foundry, you can use Solidity, whatever language you want. And you can connect your sovereign rollup to existing chains by using things like Hyperlane, for example. And you can sort of like start thinking about creative ways in which you can connect your sovereign rollup with other chains and transmit data throughout blockchains using something like Hyperlane. But if that's not exactly what you're looking to do, and you want to have like, say like a stack that you may be more familiar with, or a stack that has a native bridge to Ethereum, we do have modular DA for the OP stack. It's something that we worked on since like last year, and it's been running on testnet for I would say pretty much the whole year, since February, so give or take 10 months, right? So the way you can interact with this, we have a testnet. So the Bubs testnet, the folks at Caldera are running that. So essentially that's an OP stack chain on top of, I believe, Ethereum Goerli, but that uses Celestia for D8. So before you try to deploy your own rollup, right, or play around with having your own OP stack chain, you can just simply take your contracts and deploy them on Bubs testnet, right? See like how much cheaper it is, and build your app with that. That already would qualify you for like our set of prices. But also you can get more creative and realize like, oh, like it's really simple to deploy my contracts to Bubs testnet, and it's really simple to also deploy my own OP stack chain, right? Which you can do by looking at our docs and following the documentation on how you could do that. I am going to go back here and I am going to shut down our sovereign EVM rollup, and I'm going to show you how to run the OP stack rollup. It may or may not take a bit, since there's a lot of sort of like dependencies and stuff that OP stack has, but let's just hope that that works in time for the rest of the presentation. And yeah, I mean, in theory, ideally the path that you should follow with something like OP stack is like, oh, you're already deploying something on Solidity, right? Deploy it to Bubs testnet, right? See for yourself how it works. Then deploy your own rollup. The reason you will want to do this, especially with Celestia DA, it's really cheap. You can build apps that like truly take advantage of the fact that transactions are super cheap. The same way that the folks at Node, something I showed the screenshot before, built a on-chain game like 2048, right? Each move that you make on that game is a transaction, but because those transactions are so cheap, you can just like build on-chain games, build high throughput DeFi applications, etc. And once you're comfortable that like, oh, I have my app, I deployed it on Bubs, I deployed it on my own like local OP stack chain that's talking to local Celestia, you can swap out the local Celestia Docker for a light node that runs on the Celestia testnet, right? And at your own discretion, maybe try it out on mainnet, but you don't have to. It's a hackathon, right? Just use testnets. And yeah, lastly, we also have an integration with the Arbitrum Nitro stack. So you can deploy your own Nitro rollup with Celestia DA. This is still sort of like in the beta phase, so it doesn't support fraud proofs at the moment. I am the person working on that, and it will be done soon, but it's not done right now for people at the hackathon to use. But you can use this version without fraud proofs. It still has all the great stuff that Nitro has, right? It has stylus, you're running your own rollup, you can transfer tokens into your rollup. You can use, again, tools like I mentioned before, like Hyperlane. And yeah, it's also pretty much like straightforward. If you try deploying this and it doesn't work, let me know. I still haven't written documentation for how you would use this, and there's also not that much documentation on how to use Nitro in general, so I apologize for that, but yeah. So we may or may not have had an issue with the Wi-Fi and pulling the images for OP-Stack on Docker, but that's okay because we should be able to. Let's see. Maybe showcase the Arbitrum rollup. So with that in mind, so we have two sort of like categories for prices. We have the modularizer category, that's $8,000. One person gets $2,000, 4 other people can get 1,000, and 4 other people can get 500. This is essentially for deploying your already existing app on a Celestia rollup. So deploy it on Bub's testnet, deploy it on your own rollup. That would give you higher chances of qualifying for these prices. And deploy your own sovereign EVM rollup with Rollkit and Polaris. And my recommendation is that there's a lot of cool like cross-chain stuff that you can do if you just think about using something like Hyperlane. Like how can I get, say, like maybe the result of some contract that I built with Axiom on ETHL1 and sort of like transfer that data to my own rollup with Hyperlane. So if you're thinking about building anything that's cross-chain and whatnot, highly recommend that. It's really not that hard to qualify for these prices. So if you're already going to build something using Solidity, like think about it. It's pretty straightforward. Use whatever stack you want. If you want to build something with Nitro, right, because you want to build something with Stylus, go ahead and use our integration and qualify for both prices, right? Like Arbitrum prices and Celestia prices. And finally, we have like a little bit more challenging price of $2,000 Rocket and Rollup Rumble, which essentially all you have to do, famous last words, is to introduce a new stack to the Celestia family. So you can take something like our OP stack integration. These are just some ideas that I had like 30 minutes ago, but you can swap out where you're settling, right? So OP stack chain settles on Ethereum L1, and some people may build like OP stack layer 3s, but to qualify for this price, you could, for example, make an OP stack chain that settles on something like Gnosis chain, the Filecoin FEVM. Maybe you make a rollup on Chiliz that uses their fan tokens in some way, right? Or maybe you make an OP stack or an OP stack rollup that settles on Neon EVM. So now you have like the first OP stack rollup that settles on Solana. And another way you can also qualify for these prices is to take an existing rollup stack and modify it to use Celestia DA, right? So CK Sync, Scroll, etc. They're out there, you know. These are more for like the backend developers. I mean, this is like my job. I find it fun. Hopefully you find it fun too. And let's see. Okay. May or may not be running. Oh, sorry. Let me run that again. But I believe that's, that's pretty much it for sort of like the presentation. Let me see if I can actually get this thing running locally. But in the meantime, while this runs, if anyone has any questions, more than happy to answer. Oh. Give me a second, but yeah. Already allocated. All right. Yep. If you don't have any questions at the moment, I mean, you can just reach out to me on Twitter. We also have a support channel for the entire hackathon on Telegram. And yeah, ask any questions that you may have on like how can I qualify for the Celestia prices, or how do I use any of these integrations, or how would I recommend you to like start looking at certain code bases like Scroll or CK Sync, etc., to modify them to make your own like new rollup. Yeah.
you. Oof.
That's dangerous.
Yeah, we'll put this down here.
Yeah, better, better.
Okay. And I just plug it in.
Which one? You need USB-C?
Yeah, USB-C works. I just gotta prep. Cool.
There we go.
Make a new thing. Grab my slides. Do swap. .net. ETHGlobal. Perfect. A little last minute. Reusing some slides. Cool. Good to go. Okay. Just start a timer. Cool. Welcome. Can you guys hear me? Awesome. So I'll be explaining how to use Uniswap and Suave together. Suave is a platform from Flashbots to do confidential computation and have private data storage catered towards MEV use cases. I'll explain all of this shortly. Just wondering, quick raise of hands, who is familiar with MEV? Okay. Of those who raised your hands, who thinks they have been affected by MEV before? Okay, nice. Okay, about half. Okay, sweet. Cool. Yeah. So I'll get into it. Hopefully, we can design some things at this hackathon to help mitigate the negative externalities of MEV. And yes, again, this is in collaboration with Uniswap. They recently dropped their V4 hook design, and there's a lot of synergies between the two. I'll mostly be focusing on the Suave part, but when we get into some example ideas, you can see how it's useful. This is our docs. Please go ahead and scan the QR. We have it password protected at the moment, but we're just freely sharing the password around. There's still a couple rough edges, so this, developing on Suave is definitely for more of the explorer type, but we are here to help you out, so no worries. Okay, cool. And these slides are also from a researchathon I just gave, so I'll probably be fast forwarding through a couple parts. Yeah, so I'll mostly go through some Suave in the abstract, some fundamentals, and then some Uniswap ideas. We'll skip this. So yeah, reasons to use Suave. Right now, there's a lot of applications that utilize whitelists, so like running off-chain auctions for state accesses. I won't name any of the specific ones, but this really isn't like the DeFi ideal in many cases that we had imagined, sort of these lists that we hold on private servers, and you may or may not have access. So we're hoping Suave can help fix that. Remove or reduce staking requirements. So there's some examples of solver platforms that are unable to sort of like protect or properly enforce like correct behavior, so they like resort to slashing. And in some of the most popular cases of this, like in solving, for example, there's like over 100K USD requirements to stake in order to participate. And so using a like credible computation platform where we can sort of ensure that a solution you had submitted is correct and obeys the rules of the protocol, we can actually lower staking requirements, and therefore creating a more competitive market. Cheap proofs. So right now, I think everyone's exploring ZK proofs, stuff like FHE, MPC, some of those are more multi-party computation as opposed to like a proof platform. We eventually hope to migrate Suave towards one of these new technologies, but the idea is right now that we use an SGX or trusted execution environment to sign off on computation, and that's basically extremely cheap. And we'll get into that. and then assure users. So everything is basically Suave exists as like code deployed on these SGX machines, and you can basically ensure that people are running auctions fairly. If you've ever heard of the credible auctioneer problem, one example right now is the DOJ is suing Google for manipulating ad auctions. And there's something like 30% increased revenue because not only are they the auctioneer, but they also set your bidding strategies. And so they're able to basically inflate profits. Cool. So yeah. So at Flashbots, we've had a couple MEV applications. We have Flashbots Protect, we have MEV There's been various other protocols that have come online to handle MEV and MEV redistribution. But each of them, and like we can even zoom into MEV Share has about like 4 parameters: how much a user gets refunded on their MEV, what is the distribution of the refunds, like say a searcher extracts 0.5 ETH, how much does the searcher get? They actually did work. How much does the protocol get? How much does the user get? Maybe there's even another party involved. So there's all these parameters. And also we have this model of programmable privacy where say you send a swap to one of these platforms, you can purposefully leak subsets of the information to searchers. The less you leak, the harder it is to search on it. And so the big question is like, where is the privacy efficiency frontier? And this is all to basically say there are many, many, many MEV application designs, and every person is basically rewriting from the ground up their own like private servers to handle these things. So in that sense, like Suave is designed as an open marketplace for MEV applications, which we call SWAPs, Suave applications. Some examples of existing MEV applications include private RPCs, order flow auctions, block builders, relays, shared sequencers, and basically whatever you could imagine. Here's roughly what Suave looks like. So basically, if you're, who here is familiar with SGX? Okay, two raises. Okay, so SGX is basically a type of hardware designed by Intel where they essentially bake the private key into the hardware on its construction. And then if you've ever seen, someone tried like bank robbery deterrents where they have sort of like ink inside the money. So when you steal it, it basically ruins the money and gives away that you stole the money. That's sort of how an SGX works. If you try and pry it open, you actually ruin the device and it's no longer usable. And so yes, we're essentially placing a lot of trust in Intel because they're putting these private keys in at manufacturing. But there's arguments that Intel is very incentive aligned with this design because we're basically driving more people to purchase SGX. It would be a very weird end game if they wanted to control all private keys and then suddenly just like rug everyone. It's probably much less money than they make just from selling, chips like they normally do. Suave is basically a network of these SGX nodes. SGX is also a subset of something called Trusted Execution Environments, or TEEs. So we call a node a kettle. It's a tea kettle. It's a little joke. So the nodes on the network are called kettles. They run on this trusted hardware. And they also have access to ETHL1 state that is also located on SGX hardware. The user then interacting with their front end will have some type of order flow. Maybe it's a transaction, maybe it's an EIP 712 message. They encrypt it to the public key associated with this trusted hardware, and then they send it there. And this is how you ensure that no one can basically monitor your order flow in the middle, try and steal it and put it on chain before and front run you. And then the second thing to point out is that the Suave network, these kettles can put out both bundles and blocks. So if you're unfamiliar with what a bundle is, right now there's about 8 block builders on the Ethereum network. The main units of the main unit that they work on in order to create these blocks are bundles, and this is basically you can send in 3 transactions in a bundle, and you're basically specifying I want this to go into the slot into the block and in this 3 orders. And so you can think of back running as an example where you have a swap and then you also have the back run on the swap. So the swap leaves a pool mispriced with another pool. A searcher then creates a back run which arbs this pool back, and they want them to go together because if someone else is inserted in the middle of that, they might lose out on the arbitrage opportunity. So it's basically they want these two or nothing. Cool. So Swap provides 3 core benefits to MEV applications. The first is private data storage, and I'm going to show in a bit a little bit more of a zoomed in diagram on how these actually interact in a kettle. But so private data storage, so your MEV application on Suave has access to a place where you can store encrypted information and then also process encrypted information when you upload a program to Suave, such as a MEV application. Confidential computation, that was the second part as I just alluded to. You can basically put a program on there, it operates on this private data, and ideally it leaks no information out. Although you can design a MEV application to purposefully leak information, there are use cases for that. And then sub-ETH L1 coordination time is a little bit of a marketing term. It's essentially, we do have a chain on these Suave kettles, but it's much shorter, and then also a lot of the computation is done off-chain. So you can basically you can coordinate ETH L1 activity faster than ETH L1. So yeah, the private data storage utilizes the confidential data store, and basically the key here is that swaps define the shape and operations performed on user data. The kettles transfer this confidential data between each other, so that if you hit one, you can still do a second part of your computation, potentially another one. Data modeling, so you can include anything, transactions, user ops, 712 messages, bundles, simulation results, intermediate values, partial and full blocks, if you wanted to do maybe like a shared sequencer, and social security number, just kidding, don't put that on there. It points out though that you could put a social security number on there, but if you're familiar with like the hacks that have gone on with SGX, you should sort of assume there's one like every 2 years, and so, and maybe that'll get larger. But the idea is we are running auctions on this platform, and so if you run an auction and suddenly all your bids get leaked a year later, it's not really a big deal. Whereas if you put your social security number on there, that's definitely a big deal. Cool, and then access control. So when you put confidential data in the confidential data store, you actually specify which programs are allowed to operate on your data like explicitly. So you don't have to worry about like accidentally giving, access to like some builder who will just start front running you left and right. Confidential computation utilizes the Suave chain and confidential compute requests. So Suave chain is, you can think of it as a marketplace. I said that earlier. You can think of it sort of like the App Store, right? In that when you go to the App Store on your phone, you download an app and then you start running it locally. Maybe it makes calls to a cloud, but let's ignore that for now. So in this sense, that's exactly what we use the Suave chain for, is that you upload Solidity contracts to Suave with some additional precompiles to do like cool things like simulating bundles or maybe sending it to a block builder. And then, what was I saying? Yeah, so you upload these to the Suave chain and all of the kettles keep in sync with the latest contracts. And when you do a computation, it basically uses your program on the Suave. It uses the program from the Suave chain, but it doesn't do the computation on chain. But you can define in your Suave application to push something back to the chain. So if you, one example of this is, there's this like thing where it's actually more efficient if you're making like a crazy large trade, like 100 million or something. We saw this on CowSwap, an example of this, where some DAO was like dumping a very large amount of tokens and they got a very subpar price because they just tried to dump it all at once. And like the idea is there weren't buyers of the tokens like ready to come in and buy it. So if you sort of announce like 2 days ahead of time, like, hey, I'm going to sell these tokens, then you sort of incentivize the market to be like, okay, there's going to be this big sell event, and now we can go buy it. If the, if that's the case, that's maybe not for all tokens. And then lastly would be a confidential compute request, which is a new transaction type to basically define how this computation is performed. And I'm happy to get into the weeds another time on how this works if you're working on a swap. And then sub ETH L1 coordination time. So again, although the programs are on chain, you're not actually executing them on chain and needing to go through consensus in order to output it. And so yeah, this is how we bring it all together. Also, I'm realizing this is like quite hard to see, so apologies for that. So we can see a swap dev, maybe you, they upload programs to the chain. Inside of the kettle, we have something called the MEVM. It's a modified version of the EVM, which basically gives you access to this confidential data store. And then as well, we maybe have some ETHL1 state. So say you wanted to control something about your swap based on what the underlying pool looks like on ETHL1, you can actually query L1 from the smart contract and then do some logic based off of it. And again, in this example, you can output a bundle. So some quick ideas. I'm just going to run through these. So you can do dynamic fees such as an MC-AMM or a DMC-AMM. These are ETH research posts. Definitely check them out. I don't have time to explain all of them. There's essentially the idea is in most pools that have high volume, the first transaction in the block is an arbitrager. So you can essentially auction off the first transaction in a pool on Suave. And so Suave will spit out a signed message, and you as the arbitrager need to present that signed message in order to be the first one to swap. And the idea is the pool would then charge you a higher fee. And so this is how you could integrate something like the before hook in Uni v4. You could also tag your order flow with like proofs or like maybe a reputation proof, an NFT. A cool idea would be like use Axiom and create some type of like proof of your trading history and like show that you were, always treating LPs very fairly, therefore you should get a good fee. And then active liquidity balancing, that's sort of been around for a while. Oh no. Oh, cool. I thought I kicked something. Okay, side quest LVR, we won't do that. Some Gort tweets, check out Gort on Twitter. So LVR minimization and redistribution. I'll skip over most of these. We already talked about the first access auction. An LVR Oracle in Suave would be really cool, where basically you can LP in Uniswap, but then you could also have preferences on Suave, where say like if it's high volatility, I'm happy to actually take prices in this range. If it's low volatility, I'd rather take a price in this range, and that's much more like expressive than what you can currently do on the ETHL1 chain, and for much cheaper. Payment for order flow is another fun idea. So you could basically sell the rights to arbitrage a pool for like an entire month, or fill all of the orders in a pool for the entire month by staking and making some commitment that you're always going to fill a user's trade like 20 bips above what the underlying L1 AMM price curve gives you at any given time. So the example of that would be, a user trade comes in, someone then, you submitted these preferences, which would then try and fill the trade, and you would fill it at a price 20 bips higher than the L1 pool by querying the L1 pool and then giving the best price you can, and then maybe you could slash someone if they misbehave retroactively. Lastly, intents and RFQs. So you could just send RFQ intents into Suave. Any of the current intent designs work. So there's user ops are sort of like intents. They're not exactly like intents. There's also the Anoma intents design, which is really cool. I'd check that out. There's also the essential intents design, which is super cool as well. So you could basically just send intents into Suave and have a program that combines them and then spits out a swap on L1. So that's like mostly what you can do with Suave. Here's again a QR code to the docs. And then I'll just quickly go through our prizes a bit. Best intent Uniswap design and POC. Up to 2 teams can receive $1,000 for this. So we have some heavy caveats on using Uniswap, Suave. It's still a in beta platform, and so if your prototype doesn't exactly work, but you have most of the design, that also can like qualify for these things. And especially if you identify a reason why something doesn't work, then that's extremely valuable to us as well. And so we're happy to, still give you a prize. Best PPOF design and POC, as I just previously got into, that's a $1,500 prize. Best Uniswap LVR design and POC, we have 3 for this. This is like a really rich design space. I would check out some talks on LVR, or I'm happy to get into that later. But essentially, LVR is the framing of like why LPs don't make as much as on chain as they do being like market makers on a centralized exchange. So this is like one of the most important problems in crypto. Best use of Suave is then also 2.5K, and there's up to 3 winners of that, and that can just be anything you want. You could even share Netflix. You could do a sharing Netflix password application. Someone actually the other day built a extra data auction, so you can actually sell on the ETH execution blocks. There's an extra data field where you can put arbitrary text. Someone made an auction where you can basically bid on the next block's extra data, and it's already live on Gurley. And then lastly, best use of UniV4 hooks as well. And so anything in that regime. Cool. And that is time. That's all I got. Yeah, I will be around and happy to answer any and all questions. Happy hacking. Yes, no problem. Oh, it's all good. It's all good.
Yeah, you can ask people to go to your booth and stuff.
Yeah.
You have like your space there.
Yes.
Yeah, have fun, mate.
Thank you.
Thanks.
I think this is it right here.
You should be able to just plug it. They will like double check with can you put it maybe it's permission stuff. Is it like
There we go. There you go.
okay. Let me just confirm there then we could
Okay. Testing, testing. Do I sound good? All right, cool. Cool. Good to go? All right. Hello, everybody. Welcome to the API 3 workshop. Real-world data for Web3, straight from the source. What does that even mean? It means we run first-party oracles, meaning we aren't the middleman. Okay? So let's get into this. Today, we're going to be doing a workshop about using our Airnode product and DAPIs, which is price feeds. We're going to do a workshop on paying on-chain royalties with any API of your choosing. Who is this guy standing in front of you and the guy next to you? I am Billy Jitsu. Everybody knows me as Billy. I'm the developer advocate for API 3. Ashar, go ahead.
I'm Ashar. I'm a protocol developer for API 3.
So double the quality. Okay, so what does API 3 provide? Well, we have Chain API, which lets you bring your own API data on-chain. QRNG, that allows us to do random numbers on-chain. And DAPI price feeds, basically price feeds that are constantly fed on-chain on your local chain. I am in a 20-minute time, so I'm going to go a little bit fast. So today's workshop is going to be used two services that we have, the Chain API plus Airnode and the DAPI price feeds. And so what is an Airnode? In short, they are smart contracts that we have deployed on every chain that you want to use that have the ability to do requests off-chain and then communicate back to your smart contract.
So if I were to just break it down, let's say you have an API and you want to call it on-chain. An Airnode is a very lightweight application that you deploy on a cloud provider like GCP or AWS, which will basically act as an adaptive layer between the API and the blockchain.
So again, how does it work? We have a contract that you have is your requester contract on the very, very left of you. And then we have our Airnode that is deployed that acts as a communication between the off-chain and your smart contract. The Airnode then does requests to our cloud provider and then talks to the API, receives the data, answers back, and then throws it back to your smart contract in a short, easy way manner. And so our other product is DAPIs, which is price feeds. So we have on-chain data feeds that we aggregate data with from multiple sources. and we grab all that data that is provable and bring it into a single price feed for you that is averaged out. You can prove every price feed is coming straight from the source based on their data feed ID, so you can prove that on the smart contract level.
So if, our air nodes, we took the concept of the air node, which anyone can deploy, and we went to very reputable price providers and told them, hey, can you run this air node for us? And they run the air node. We get the data from them, and then we aggregate it on-chain, basically providing you with data that is straight from the source and that anyone can verify where the data came from, because you can actually see the air node is hosted by Nodary or DXFeed or whichever data provider.
Exactly. So what we're going to use today is, again, we're going to mix that chain API, the off data information, bringing it on-chain, and the price feeds from DAPI, and we're going to mix the two to make an on-chain royalty payment system. So we're going to go ahead and break down the API. Usually this is a little bit more in detail, but we're going to show you how to use the chain API with a slideshow because we are unlimited in time. But let's go ahead and break down the API. So for this example, I'm going to be using YouTube. I'm a music producer. I want this YouTuber to get 1 million views. I have an agreement with this person to say, hey, if you get 10,000 views, I will pay you a certain amount of royalties over time. So what we're going to do is we go to the Google Docs, and you can see that we have a getter, which is the Google API's YouTube, which is our main link, and it has videos. If you dig into the docs a little bit more, you look exactly for what you want to see. I highlighted statistics. It's a little bit hard to see here, and it gives me all the information that what I get in statistics. And that's all in the Google Docs. And that's going to be specific for your API that you want to deploy off-chain. If we looked at that into Postman, it basically breaks down what we want to see, exactly what we want to see here. Can you guys see that okay? I know it's a little bright in here. But it breaks it down into the pieces that we need. We have the base, we have the endpoint, and all the parts that are required for it. So you'll see that we have a part, and then it goes to statistics, and then we have an ID, which is the unique YouTube ID, and then it requires an API key that I need to get permission to read that data. And then you see on the bottom the response that I get. And so what I'm looking for, based on that ID, I want to see the view count. So the view count is what the data that I want to get on-chain. So in our chain API interface, I'm going to go ahead and do my base URL, which is the Google API's YouTube v3. And then for security measures, I want to put in my API key. So I'm going to go ahead and put that API key as a query. On the next part, it's a simple wizard. As soon as it goes, I'm going to have to do my endpoint. I want videos for my endpoint. And so in my path, again, if you look back, you'll see that I have it on the part with statistics and the ID. So I don't want to hard code it to always get that same video every time. So I'm going to let the user define what they want from that YouTube API. So I'm going to let them, so for the part, I'll say it could be statistics or any other part that they want from the Google Docs. And then the ID, any YouTube ID that they want to choose. So it doesn't have to be my artist, it can be any artist. And then here specifically we have preserve types. Ashar, can you go a little bit deeper in those preserves?
Sure. It's a little bit complicated, but essentially what it is that you want a specific response within the API. You do not want the entire response that the API returns. So you have the user define the path within the API that you want. So in case of the YouTube API, if you'd go like 2 slides back, we want the view count, which is within this JSON response. It's within the items, statistics, view count field. So we have the user define the JSON path, and that's essentially what the path is within Chain API. Okay. And then there's 2 other parameters like type and times. So the type of this response is going to be integer, and the times is if, let's say, we want to multiply it because Ethereum is commonly 18 decimal places, and you have to multiply with 18. But in this case, we don't really want to do that, so we'll just leave it empty.
Yeah, for this example, we're keeping it very simple. If you were doing just a basic integer request online, you can use that as the true number as it is. So for this example, we're keeping it simple. For those that are using OAuth, we have a pre-processing and post-processing. So sometimes you have an API key that only lasts for an hour, and you need to use your authorization to do so. You can do a pre-processing before the request to get an API key as well. But for this one, we're keeping it really, really simple and just having the API key directly in there. So we go ahead and then we create that wizard. It gives us a small file, and we're going to go ahead and deploy that API using either AWS or Google Cloud or any kind of service of your choice. But the wizard helps you with AWS, so we're going to do AWS. And so when I deploy, I just give it any name I want. So I'm just calling it YouTube. And then it's going to be on my version 1 because it's going to be my first deployment. And this wizard takes you to the whole thing. And so I'm choosing AWS, and then it's going to ask me what kind of cloud providers I want. And for this one, I'm using US East, but you have multiple options to choose from. And then it's going to ask you what chains do you want to deploy on. So we have multiple chains that we support, whether on mainnet or testnet. For this one specific one, I'm just using Sepolia, but you can run this on multiple testnets if you want. If you wanted to support multiple chains. For our bounties, we have a sports API that's going to be available across multiple testnets.
Yeah, so this is particularly useful for the bounties that are available in this hackathon because we support all the major L2s as well as some of the major L1s. So if you're planning on hacking on the L2s or the L1s, you can mix and match the bounties
yes.
by deploying it here.
And we've kind of already done it for you, so you can almost skip this part. And so authorizers. So depending on how you want to deploy this to production and for testnet, you can have it restricted to only have an allow list of certain contracts or addresses that can do the request. For this example, I'm making it public to anybody, so anybody can make the request. So if you're doing it for testnet or MVP, keep it public. And then it just checks to make sure that we have all our settings are correctly, our versions, where we want to deploy it to, and the networks we want to deploy with. And then we go ahead and gives us a package that we download. And so on the very, very left, you'll see the package contents. It'll have an AWS env, config, JSON, README, and a secrets. In a sense, all you have to do is fill in the AWS, where you have to do your access key ID and your secret access key, which is on your AWS account. And then on the secrets.env file, it's going to ask for a wallet mnemonic. There doesn't need to be any funds. The way this system works is somebody has to pay the gas. So when you send a request and get a response, you pay for the request on your first transaction, but then things have to happen a few blocks later. And so somebody has to pay for the gas to get that response. So the sponsor wallet will do that. And this mnemonic generates a sponsor code for then you to fund a little bit later. So it doesn't have to be a funded wallet. It just has to be a random mnemonic. You can make this with a generator or open up MetaMask and just make a brand new wallet and then use those keys. There's no funds required on that. And then depending on the testnets that you supplied, you have to make sure that you have a RPC address. I just went to chainlist.org and then just grabbed a random one. If you have one that you want to be a little bit more solid, you can get one from like Alchemy and Fury or any of these other RPC first providers. And then I'm also inputting my API key for YouTube. This is where you keep it secret to deploy it. So I just have my API key. I already burned it, guys, so don't bother using it. But just for the example, I wanted to show that. That's where you're going to input your API key. So that way it stays on the air node, and then you don't have to give that out publicly. It's not front-facing. Okay, and so then once we deploy it, it's going to go ahead to deployment, uses Docker, deploys it, you'll get a success, and then you'll get more files in your folder. And this is the stuff you really, really need in order to use it at the smart contract level. You'll see that you have 2 additional files. You'll have a receipt and log files. And so in the receipt, you're going to get your air node address that's specific to your chain. That's what you're going to use to communicate with our air node smart contract. It's also going to give you an air node extended public address that you'll be used to generate your sponsor wallet. And then in the configuration, you'll also have your endpoint ID. This is the endpoint ID that you'll use to communicate with the API scheme, or sorry, the links scheme. And this is what you're going to need to actually deploy with your smart contract. Anything to add on that?
Yeah, I'll just say that this all seems a little more complicated than it actually is. Once you run through the wizard, the only thing you actually need to do is just deploy the air node, and you're mostly done. And then you have an on-chain address for your API now. Anyone can call that on-chain address and in effect call your API. Yeah. So we are just going through this pretty fast, but I think overall the process is much simpler than it looks.
Yeah. For those hacking with the F1 sports feeds, basically you could skip this entire part because we already did it for you, and you have the air node address and the endpoint ID to work with already. So this would be the only need. We'd need the smart contract addresses. Okay, so I am not a big fan of PowerPoints. I like breaking down code and talking about code. That was the off-chain data stuff. So let's go ahead and build out how we would actually build something here on the space. So let me go ahead and open up my thing. So I know the code looks a little bit scary because it's a lot to swallow, but let me go ahead and Control+ that. But let's go ahead. Oh, sorry. Oh.
More.
Boom.
Cool.
Okay, better? Hopefully? Okay, and let me go ahead and minimize this. Okay, so the proxy address for reading our API price feeds is really, really simple. Literally, you can see like it's 23 lines of code, including my spaces. All it requires is one import for our iproxy.sol library. And I just have one public variable to set our proxy address, which is basically the price feed we're going to choose. Our constructor doesn't require anything. And what we're doing here in this function is literally setting a proxy address. We're telling our smart contract what price feed are we looking to look at. So let's say we want to do ETHUSD or wrap BTC USD. We get to choose whatever proxy address we want to do. And then we literally just read the data feed. And so it's a very, very small lines of code. What we get in return is we get the value, which is the price of the asset at that specific time, and the timestamp of when it was last updated. So we have a certain threshold of 24 hours or a change in deviation of price. If we go over to our marketplace, you can see that we have this one specific one on mainnet. We have a managed DAPI, which is a option of 0.25% deviation, 0.5% deviation, and a 1% deviation, meaning if ETH is $1,000 and it changed price to $9.90, that would be a 1% change of deviation on chain, and then they would automatically update. And so for smaller deviations and change in price, it would update more frequently or within 24 hours, depending on the range. And you can see that we have current sources. You can actually look at yourself. If you look at the details of what we're getting on chain, we're getting multiple sources from that specific price feed on that specific chain, and we're aggregating all that data down to get you your specific price. And so that is how you would get the market feed on there. And then the second part of this is a request response. Let me zoom in a little bit more here. This one looks a little bit more complicated, but let me break it down very simple. Our request response is basically if you get a request transaction, it's going to call out to the air node, and then it's going to respond. So we have this make request, and we have this fulfillment. What do we do when this number comes back? Our request parameters that we have here is the 3 functions, is basically telling us what chain are you using, so what air node should we port to, what endpoint are you using, so where do we point to, and then who's going to pay for the gas. And that's pretty much our setup. And so the make request is a pretty standard boilerplate code. You don't really have to change too much around it unless you have something very, very specific out of the box that you're trying to do. And all the magic happens on the fulfillment. So when we get that number in return, or that answer of what we were requesting in return, once we get that answer, what do we do with it? What is the smart contract logic that we're going to do? And I'm literally saying do what you want in this middle of the array here, so then you can go ahead and see that. So let's look at this royalty code, and we'll break it down piece by piece. So this is the music label royalties on-chain system. So let me just break it down really quick. As like we said before, it's in multiple sections, so we're combining the 2 libraries, request response and the DAPIs. So what I have here is my set proxy address right here hidden. I want to say what asset am I looking to pay with? So I'm going to do ETHUSD. On my set request parameters is basically saying what chain I'm going to do this on, what endpoint I'm going to do this on, which is my Google endpoint API, and then who's going to pay for the gas, which we're going to generate in just a moment. And then we're going to make the request. The only thing that I've changed here is who am I requesting to. So I am doing a request for this one specific artist that I have. So I'm going to register that artist with a specific wallet. So when I do that ID and make sure that they hit enough hits, I'm going to go ahead and make sure that it's that artist. If I have multiple artists, I'll have multiple IDs. So I just have an input to check for that ID. And then the fulfillment array is once we get that view count from YouTube, I'm going to say, well, now that we have the YouTube, what are we going to do with it, right? So the return response is going to give me a number of how many views it hits. And then I'm going to call a function, which is this function right here, which is called payout. I'm going to try to highlight it just a bit. Oh, sure, of course. Better?
A little more.
A little more.
More. Okay.
Perfect. So this payout is just a function that I made to have the logic to be able to check to see if it hits the requirements, if we hit any agreements, if they had 10 views, 100 views, 1,000 views, make sure it's going to check those balances to say, all right, you've hit the requirements, let's go ahead and pay you out. And then now we're going to go into the data feed, right? So we go bring in this DAPI, and you'll see that we have our price feed, right? So we're just basically reading our proxy data, which is going to be ETHUSD. We're going to see the value, we're going to check the timestamp, and we're going to say, okay, this value is legit. Let's go ahead and make sure that this value pays out on that value. And then here is my payout function, which is more logic than anything, is basically saying, okay, has this person hit the milestones? If the milestones have been met, let's go ahead and make sure the views haven't been paid out already. I want to pay you out for 10 views, 100 views, 1,000 views. I want to make sure I'm not paying you twice, so just some checks and balances. Here I'm actually checking the price of the data feed. So I'm going to check to make sure ETH is this price, so I can make sure that I pay you $100, $1,000 in ETH. ETH changes dynamically, so we want to know at that moment what the price of ETH is. And then I'm doing some conversion. I'm changing it to dollar value. And then I'm making sure that my smart contract has enough funds to pay the royalty out. And then I will then pay that specific artist their bounty. Very, very simple breakdown in here. And so the way we get this all set up is, I have all my variables on here, which should look familiar. We have our Airnode, sponsor wallet, and endpoint ID that we need to set up parameters, our proxy address, and then I have a global variable for the return response, so you can see simply what the return response that I got. And then I've created another artist ID variable to make sure that I can have multiple artists on here. So if I sign up one artist, their ID 1, 2, 3, 4, to whatever they want. And then I just have a simple mapping to make sure that I have fulfillment requests, because if we do more than one request, we have to keep track of how many requests are being sent and how many requests are being returned to make sure that we're not getting any faulty data. And then I'm also keeping track of how many milestones have been paid per artist on there. And then this is a quick sample of what the milestones are. I'm picking up any random one, so I want to make sure like some YouTube video got 10 views, 100 views, or 1,000 views. It could be 1 million views, whatever is discussed beforehand. And so I went ahead, the internet is a little funky sometimes at hackathons. It wouldn't be a real hackathon if the internet worked right out of the box. So I went right ahead and deployed it. Okay, and so you can see that when I have the deployment, I have to deploy my Airnode. So we can go to our providers, and we want to make sure that for this case, I'm doing Sepolia. So I am grabbing, excuse me. Let me go ahead and zoom in. I am grabbing our Airnode that we have specifically set for our Airnode at Sepolia Network. And you can see all our test nets have all Airnodes deployed on every chain that are available. And so I've already gone ahead and deployed that. And you can see that I have my music label already set. And so I am setting my proxy address because I want to make sure that my smart contract reads the ETHUSD price feed. So I'm going to go ahead to the API3 market. I am going to the Gurley testnet, and I'm sorry, Sepolia testnet.
I think one thing to keep in mind is that the reason we are using the ETHUSD feed in this contract is that we want the user to be able to pay in ETH, but we charge them a set amount in US dollars. And that's why the data feed is necessary. But you could do this with any of the assets that are listed on the market. So let's say you want the user to pay in a specific currency, maybe not ETH, maybe some other currency. You could also do something of similar. The one thing, like I've seen a similar concept with someone building here in the hackathon, that they are building like a Fiverr on-chain. They wanted to charge people in USD. And what I recommended to them is do something similar as what we are doing here, is that you just use the data feed to calculate how much ETH you would need to pay for an equivalent amount of USD.
Right. So don't confuse the data feed ID with the proxy address. The data feed ID is up on the top. That is a unique ID for that price feed. The proxy contract address for your smart contract to read is on the very bottom right here, which is the proxy contract address. So you would copy that out and then go in and then set your proxy address. So once we have our parameters, once we have our sponsor wallet, everything set up, now we can request to say, okay, we want to get those IDs. If you follow the repo, we have this encoding structure. You can encode it on the smart contract level if you wanted, but that would require it to be hard-coded. So we have this JavaScript function on the repo where you can then set your parameters and say, all right, I want to get this specific YouTube ID, which is this ID that we have for this one YouTube video, and then I want statistics, and then basically breaking it down on that original JSON response. I want to get the items, statistics, and I want to go specifically to the view count. So you can modify this API to whatever way you want. It's converted into the bytecode, and so you'll see this big, long script of bytecode here. We would grab that information, pop it out into our code, and then we would make our request. And then within our request, we would say, okay, let's go ahead and make our request for here. So we want to see what the statistics counts are for that specific YouTube ID. I've already registered the artist because we have limited time, and that artist is 12. I would make the transaction. It would do the transaction, request, and then based on the sponsor wallet, depending on the time we have, it would then fulfill our request a few blocks later because we have a request received. So we would send out our transaction. It would grab the API a few blocks later, depending on the chain you use on. It would send a fulfillment request, and then we would get it back.
Can we do it in real time, the request?
We can. We got like 1 minute left.
Sure,
yeah.
sure.
So that's why I pre-deployed it. So if we look right now, I'm going to look at my request. My return response is I'm going to try to zoom in as much as we can. 792, 353, and on that YouTube ID that I used for this one random one right here, it says 792K views, so it averages it down. So you get the exact view count that we get from the API, and then it'll automatically play it in the smart contract level. And then once it goes, it'll distribute all the ETH available to it. So I put this thing with like 0.1 ETH on the smart contract, and it paid it out to the artists that are available and paid out directly. I know that was a lot to swallow. I had 20 minutes to fix that in. So we are in the booth. We can help you deploy your Airnode. We can help you set up your request response, your DAPIs, and if you're doing random numbers, we can definitely help you get that set up as well. Just to really quick before we go, talk about our bounties. Let me go ahead and slideshow this really quick. It's going to take me to the very beginning. There we go. And so we have the best use of DAPI price feeds, which is going to be $4,000. The best use of QRNG, which is our random number generators. We've seen plenty of Uniswap forks. We've seen plenty of lotteries. So spice it up a little bit. You saw the creative usage that I was using for the price feeds to just check the price to make sure we pay out an ETH and dollar value. And then we have 3 API runners up, $1,000 each, to see the best creative idea using any of their technology. If you have any questions, I'll be at the booth all weekend long. It's going to be a grind, guys. Thank you, guys.
Thank you.
Yeah. Yeah. Really? No, 4:26. You said 4:30. No, it was 20 minutes. You said 4:05. No. No. No. Anyway, good job. Yeah.
It's good. We have 5 minutes to make sure everything is working. Does this work? Oh yeah, it works. Hello. Hi.
You need an adapter?
No, I have HDMI on this side. Where is it? Okay. Let's make sure I don't have any porn open.
I don't think people will mind.
I don't know.
That will be making
I don't mind.
fun.
Could be fun. Maybe my employer will mind. Hey man.
Porn snap.
How does it work? Why is it not working?
Is it maybe something from the set?
It just takes time. No, it's working. No, it's not working. This guy in the back is doing something.
You sure it's not something from the settings of your laptop?
Nope.
Mirroring something?
100%.
Okay.
We can try with this USB adapter maybe, but no, I'm sure that it's.
You start fine.
All right, let's try with USB.
Yeah.
It's good. I came early. We have time.
Yeah, no stress.
Where is the? Oh, here. Maybe this one will work.
Any problem? Doesn't mirror the screen.
MetaMask snaps. Bye. No?
So you will have 30 minutes?
30?
Yeah.
Okay, good. I heard 25, but I'm happy to have 30 minutes. I like to talk.
Keep it within 25.
Yeah,
and
I
then
know.
you have 5 minutes for
questions.
right?
Yes, I know.
How I usually did it, if I come here on the front row, that means we have 2 more minutes. So that otherwise I don't
Perfect.
signal.
Perfect, but it's still not working.
He went for someone to help us.
That's weird though.
Yeah. No, this thing is good.
Everything looks good. I'm sure we'll get it working. It's good. Waiting for more people to come in anyway. It's not a bad thing. We're gonna do some stretching. Oh no, why are you leaving? Why are you leaving? Stay here. Okay, bye. See you later. It's good. Don't worry about it.
Oh, and if someone has questions.
Oh, now it's working.
There we go.
Ah, there you go.
If someone has questions, please repeat it in the microphone.
Always.
before the
Always.
stream. Good luck.
Thank you. I don't need it. All right. Hello, Istanbul. Hello. Hi. Raise your hand if you're a developer. Okay, keep your hand up. Don't turn it down. And raise your hand if you're not a developer. Okay, keep everyone your hand up now. Everyone up. Up. Okay. Now raise your other hand and give me a big nice stretch. All right, now I have everyone's attention, so we can get started. Let's do this. And by the way, you notice the screen is a little bit small, so don't be shy if you want to come to the front so you can see a little bit better. And we're going to get started. Welcome to the MetaMask Snaps workshop, everyone. Thank you for being here with me today. My name is Ziad Saab. I'm the developer advocate for MetaMask Snaps. So my role is to help the developers to get started working with snaps, to get started hacking, whether it's on our bounties or whether you're going to make a production project. And I prepared a little workshop today for you. You don't have to use your laptop or anything. You just have to listen to me and breathe. And I see there's a lot more people who just came. So for the new people who have arrived, we're doing a MetaMask Snaps workshop. Welcome. Thank you for being here. And just before you arrived, we were doing a little stretch. So if you want to stretch, don't hesitate. It's going to make you feel more focused. It's always nice. All right. And all right, let's get started. Before we do, I have a few QR codes for you, okay? This QR code is for our developer chat, not just for MetaMask Snaps, but for all the consensus products. Okay, that's MetaMask Snaps, SDK, Linea, all our products. So this will give you to our Telegram chat. Scan this QR code. I will give you 30 seconds to do that. See, there's a lot more people coming. Hello, welcome. Make yourself at home. This is a QR code for our developer chat. And 1, 2, 3, I'm going to change the slide very soon. And this is another QR code. This one is for this presentation. Okay, so this is a QR code of the presentation that you're watching. I'm giving this to you because there's some resources at the end you can click on. There's a lot of links for documentation, and also that you have my face, my beautiful photo here. So this is QR code for this presentation that we're watching right now. Also take a few seconds to scan it. And if for some reason you can't scan it, you can come see me later and I will give you any information you want. All right? Good? All right, let's do this. So we're talking about snaps here. And I'm going to talk to you about our bounties later. But first, I'd like to let you know a little bit, for those who don't know, what is MetaMask Snaps? Okay? Some people will tell you, plugins, extensions. This is how I like to talk about MetaMask Snaps. It's community-built features for MetaMask. Okay? Who's the community? You guys, everyone. Okay? And why are we doing this? So that you can extend the wallet, add new features to it, in a permissionless way. Anyone can start working on snaps today, and we have a lot of bounties I will show you later. And now I'm going to tell you a little bit about what are some of the things that you can do with snaps. Okay? So we're going to talk about some of the features that you have available to you in order to develop with snaps. The first one, this is the biggest one, it's very important, is you can derive private keys for any protocol. Okay? So that means today, you can manage Bitcoin, you can manage Solana, you can manage all kinds of assets in MetaMask. It's not anymore just Ethereum wallet, okay? We have all these snaps are available today live in our store, snaps.metamask.io. you can go, you can install these snaps, and you can start playing with them and managing other types of assets. I have a video here. I don't know if it's going to work because the network is a little bit slow. We're going to try it. And this video is showing me using the Bitcoin snap that we have on our store. So you can make Bitcoin transactions. You have a confirmation window. All of that is using the secure enclave of MetaMask snaps to manage the signing of the transaction. And then you have a dApp that is showing you the wallet for Bitcoin. And it's very exciting. As I said, snaps.metamask.io. You can go there and you can install all these snaps today live in your extension. Next feature, also very important. I can't say that every feature is the most important. Otherwise, you're going to think like, what is this guy talking about? But we have a lot of snaps that are being built today to add security into the wallet. Okay, MetaMask is already very secure, but sometimes you're very excited, you get a Twitter link or something, it says like, I don't know, like mint this token or whatever, you don't know what's going on, you want to do it very quickly, and you click confirm, and then suddenly all your assets are drained, right? We can have the most secure wallet possible, but that's not going to prevent some user errors, okay? So what is this feature? We call it transaction insights, okay? So you can create a snap, just basic JavaScript code basically, that will receive the transaction before the user clicks confirm, okay? So you have access to the transaction object and you can do whatever you want. You can call some private APIs, you can run some simulations, and you can present to the user an interface, and you can tell them maybe like, oh, you should not execute this transaction, this will drain your wallet, or this address you're about to send funds to is known to be a malicious address. And this is an example. It seems that we have a pretty good connection here. So let's look at this video. We have a test dApp where I'm trying to make a malicious ETH transfer. And in the transaction window, you have BlockFence, which is one of the snaps that we have available in our store today that is showing me that it's a bad transaction. And it's very simple to create a transaction insight snap. You create a piece of JavaScript code that has an on-transaction export, and you get access to the transaction object, and you can do any kind of operation you want on it. Like I said, you call your APIs, you do some simulations, and then you request the permission to run those insights, and you can do a lot of things with that. If you want to look at some examples again, snaps.metamask.io, you can get some inspiration of all the snaps that are available today. And we really hope that you build on top of these features. We have some really great bounties for you today. You have a question? Yeah. Okay. Is it possible to introduce on approval transaction? Is it possible? No, you mean for ERC20 transfers? When I need to approve a transaction and MetaMask opens, can I run insights there? When you need to approve a transaction, can you run insights there? Yes, this is what those insights are for. No, we still don't have insights for ERC20 transfers. We have insights for regular transactions. And we just launched a new feature where we have signature insights. So when you have a pop-up for signing, just for signing a message, we have insights for that now. And we are working to add insights for allowances for ERC20, but we don't have it yet, but it's coming. There's a lot of features that are coming. And there's a link that I'm going to give you also at the end that is another Telegram chat where we put all the announcements. Every time there's a new Snaps feature, we will put it there so you know that it's available. And there's a lot of very exciting APIs that are coming. Super, super exciting for account abstraction, MPC, a lot of very exciting things on the way. Thank you for your question. Please feel free to ask questions at any time. You don't need to wait until the end. Cool. All right, let's keep moving. So, apart from these two APIs that I just mentioned, right? We have a lot of supporting APIs, things that you're going to need to build your Snap, right? So we have encrypted storage. You can add some data inside your Snap, and it's really cool because it will be available across all the websites, right? So you can do some really interesting things with that. Confirmation dialogues, cron jobs. So a lot of people ask us, do you have WebSockets in Snaps? WebSockets are not available, but you can run JavaScript code on a cron job on the clock every minute or whenever you want. You can pull some data, and give the user some insight about their NFTs, about their anything that they want to monitor. You can do a lot of things with that. And another really cool feature that we launched very recently, which is localization. So you can make your Snap available in the language that the user chose in their MetaMask extension. And it's very easy to do. Super easy. You can localize everything you want in the MetaMask UI. And there's a lot more to come. So now you know what you can do with snaps. You want to know how to get started? It takes 5 seconds to get started to create a snap, okay? First, you install Flask. What is Flask? Flask is MetaMask, but for developers. So it's the same extension that you already know, except it has a purple fox icon instead of an orange fox icon. And you can use snaps in it without needing to be on our allow list, right? Currently, Snaps is working on an allow list model. So before your snap can be installed by users in the main extension, it needs to be audited and we need to approve it. But you're at the hackathon now. You want to start hacking on snaps. You don't have time to do an audit and for us to approve you. So you install MetaMask Flask and you install it in a new browser profile. You cannot install it in the same extension as MetaMask. And this will allow you to develop snaps, right? You're going to use a new set of private keys. You don't want to use your precious private keys with Flask. But this is the first step. So you install the developer preview of MetaMask. Step 2, you go to your command line. You run yarn create @metamask/snap, the name of your snap. Okay, you don't start taking notes. The presentation will be available to you later, and I will be available to you as well. Okay, so this is very easy. It's like a create React app, right? You just run this command line. It's going to clone our template, and then you can immediately get started. And we have a development server available for you. So that's the third and last step. You just go into the directory that you just created. You run yarn start. And what happens when you run yarn start? You're going to get this. I'm going to make the font size a little bit larger. Don't worry about it. I'm coming for you. All right, here you go. So you're going to get a development server that will run, and it's going to run 2 servers at the same time. One server will be running on localhost 8000. The other one will be running on localhost 8080. Okay? So what happens with that? So you're developing, right? So you don't want to have to recompile manually every time. Same thing as a React app, right? Your snap is basically just a bunch of static JavaScript code. So in production, you host your snap on NPM. But while you're developing, we have a server available for you, localhost 8080, and every time you make change to the snap code, it's going to automatically recompile that code. And the other server running on localhost 8000, that's a dApp. It's just a regular app that we built using React, and that makes it easy for you to test your snap. Okay, you don't have to use this dApp in production, but it's already wired up to do everything for installing the snap, for reloading the snap when you make changes to it, and it has some example code for how to communicate between a dApp and a snap, right? So how does it work? It's very simple. When you load the localhost 8000, you're going to be presented with an interface that's very familiar. I'm going to keep making the font size bigger until we can actually see something here. You're going to be presented with something that's very familiar. Anyone who uses MetaMask is already used to having the Connect MetaMask button, except in this case, when a user will press the Connect to MetaMask button, it will ask for, I hope I remember my password. This is not my real password. All right. And so what it will do is it will ask for a connection request to install the snap. I'm going to try to make this also a little bit larger so you can see what's going on here. So basically it's saying this website, this dApp, wants to connect to a snap hosted this time on localhost 8080. In production, it's going to say the NPM package of the snap. And then you say connect, and what do you see next? You're going to see the permissions that the snap is requesting. Okay, so this is very important. We're going to stop here for a second and look at this. Snaps are not allowed to do anything by default. They can't communicate to the network. They cannot bring up dialog windows. They cannot do anything that the snap will want to do, deriving private keys, asking for transaction insights. The snap needs to ask for permission in order to be able to do that. And this is what this dialog is showing here. It's showing that this dApp wants to install a snap called TypeScript example, and the snap is asking for some permissions to display dialog windows and to allow websites to communicate with the snap, right? So snaps can expose an API. And for example, we saw me interacting with the Bitcoin snap earlier, right? So the Bitcoin snap exposed an API that allows me to send transactions, to sign transactions, to check my balance, to do all of these things. And it has to request permission for all these things, right? So before we move on, how do you request these permissions? Well, it's very simple. In the code of your snap, we're gonna look at a little bit of code later, but in the code of your snap, you have a file. It's a manifest file. If you've ever developed extensions for Chrome or for any other kind of plugins, there's a manifest file that contains all the information, all the data of your extension, of your plugin. And Snaps is no different. And as part of this manifest file, we list all the permissions that the Snap wants to use, right? Like if my Snap needed to make a network request, if it needed to connect to the network, I would add a new permission here. It's called endowment network access. So you would add this permission here, and then the fetch function that you're all familiar with if you develop with JavaScript will suddenly be available to your Snap. If you don't have this permission, you can try to use fetch. It's not going to work. It's going to tell you that it's blocked. And this way your users will know that your Snap is trying to, is needing to connect to the internet. Just like permissions on the apps on your phone, anything. And anything that you do in your Snap, you need to request a permission. So when I click install, the Snap is going to be fetched. It's going to be installed in my extension. And now the code that we give you for this demo dApp is automatically going to detect that the Snap is installed and is going to change the interface. And I can just show you an example. If I click this send message button, what's going to happen is the dApp is going to communicate with the Snap through its RPC API, and it's going to pop up a dialog window here. This dialog window that you see here is coming from the Snap, right? You can see that it says TypeScript example at the top, which is the name of this Snap. And it's just a regular confirmation dialog. You can use it before signing a transaction on behalf of your users. You can use it for doing anything you want. And this is just some sample code, right? So if I click approve or reject, nothing is going to happen right now. But this is the sample code that we give you, that we make available to you. All right, so we still have quite a bit of time. I'd like to show you, since you're going to start developing with Snaps, I'd like to show you how you can debug your Snaps, right? Inevitably, you're going to run into some problems when you're developing your Snaps. You're going to get an error, and you're going to be like, okay, well, what's going on? I don't see any output. And the first thing we do as developers, what do? We open the developer tools, which are also super small, all right? We open the developer tools, and if you open your developer tools and you go in the console here, you're not going to see any errors that are coming from the Snap code. Why? Because the Snap is running inside of the MetaMask extension, okay? So how do you debug the MetaMask extension? Very simple. The way I do it is I will right-click on the icon of the extension. I will go under Manage Extension. I will make sure that I am in developer mode here, which I have to enable. And once you enable developer mode, you can inspect the background.html view. It's going to open another developer tools here. And in this console is where you're going to see the output of the errors or the console logs that you make inside your Snap. I'm going to make one very quickly just to show you how, when you make changes to your Snap, because you're going to be doing that, how you can reload those changes and make sure that you have the latest code available. All right? So this is going to also allow me to show you where a little bit where all the code is, right? So this is the code that gets created when you run our yarn create command. Is it somewhat clear? Like it looks very small from, yeah, it looks a little bit small, but I can't make it any larger. Otherwise, we're just not going to see anything. All right, so this is set up as a yarn repository with workspaces. And you have two packages. You have a site package, which is, like I said, it's a regular React dApp. It's built using Gatsby. You don't need to use any part of it, but you can just look at it to see what are all the Snaps functions that you can use in order to install a Snap, in order to call its RPC API and all that. We're not really going to go through it. And then you have the Snap package, which is all your Snap source code. And we already looked at the manifest file, which contains the permissions, the name of your Snap, and whatnot. And then you have your regular source directory. And really the only file that you need is an index.ts, right? Now, if you start developing a big snap, I'm not going to tell you, but you're going to modularize your code. You're going to have a lot of files with a lot of modules. But really the only important thing is that your code, if you need to expose an RPC API, is going to, your index.ts file is going to export a function called onRPCRequest. This is how we know that you want to expose an RPC API. And this is when I clicked on send message earlier and it popped up this dialog window, this is the code that pops the dialog window, right? We have a global snap object with a request function, and we have a snap dialog function, and there's many types of dialog. There's confirmation, there's a prompt dialog, all sorts of types of dialogues. Everything is very well documented in our documentation, which is linked at the end of this presentation. And all right, so let's just make a little change here, okay? So I'm gonna assign this to a variable. I'm gonna say result equals await, and then I have to make the function async here, and then I'm gonna just console log the result, and then I'm gonna return it. Okay, so we can see what's the result of doing a dialog, and I'm gonna say result, and then I'm just gonna return true here. And I don't know why it's bothering me. Okay, well, whatever, it doesn't matter. I like to do lexical declaration in case blocks. I don't care. I will just disable the rule later. But this is not going to prevent anything from happening. So we're changing the snaps codes. First thing you can see is that the snap code was rebundled automatically. In the terminal output, you can see that it was rebundled automatically, but I still have the old version of the snap installed in my browser, right? So I have to reinstall the snap. How do I do that? Very easy. We have a reconnect button that we made available to you. All it does is it just reinstalls the snap. So it's the same thing again. Maybe there's some new permissions, so we still need to show you this dialog. And then I click install, and I have the new version of the snap with the console log that was just installed now, okay? So we still have this other developer tools that is running here. And now if I click send message, and we still get this dialog, confirmation dialog window. So let's say I click reject, for example, and then we'll see here a console log coming from the snap, and it says result false. So this is the result of bringing up a confirmation dialog and clicking on the reject option. And you can imagine that if I click on the approve option instead, then I'm going to get somewhere result true right here. So this is how you debug a snap, right? You just put console logs anywhere you want, and then you open the background.html developer tools window, and you can see any errors, you can see stack traces or anything you want. So far, so good? No questions? Amazing, I love that. All right, let's keep going. So we know how to create a snap. We know what are all the supporting features of snaps. What do we do next? Well, now you can start hacking on snaps. So let's talk about our bounties. We have $10,000 of snaps bounties available. In total, in consensus, we have $20,000 of bounties. I'll talk about all of them later, but for snaps specifically, we created 2 bounties for you. One of them is you build any snap. Okay, we don't even want to limit you. Just build anything you want. Make sure it's innovative. Make sure that it's functional, that it works, that we can test it once you're going to submit it to us and present it. But you can do anything you want. Add a new blockchain. Add 3 new blockchains if you want. I don't care. The more you do, the better. Increase safety by adding some transaction insights. We have some really good APIs for that. Decentralized identity, communication. We have a snap called Wallet Chat that does wallet-to-wallet communication. It's really, really cool, and it has notifications built in. So impress us. The sky is the limit, really. We really want you to build something cool. Yes?
The question about snaps and account abstraction.
Yes.
Is it possible to have your account abstraction smart contract wallet inside the MetaMask and connect this to the protocol as a Uniswap or something to use?
Okay, the question is, can you create an account abstracted account inside MetaMask and use it as any regular MetaMask account? Okay? Soon. Very soon. I cannot wait. I cannot wait to come to a conference and to be able to tell you, yes, we have this available, okay? We have the accounts team at MetaMask that is working on an API called the Accounts API for Snaps. Today, it's available, but only to create like MPC accounts or other kinds of like custom EVM accounts that are fully plugged into MetaMask. And like you said, you can connect them to Uniswap, you can do it, they're fully integrated in MetaMask. Soon, this same feature will allow you to create 4337 accounts that can return a user operation, and we will submit it to a bundler, and everything will be magic and it will work perfectly. And I cannot wait for this feature to be live. But we need to put security first, and these things take a lot of time. But today you can still create account abstraction snaps, but they will be a little bit less integrated. Thank you, Colin. Is it worth it to build an account abstraction snap right now since it's not going to be fully integrated into MetaMask? I understand. I would say that it's still worth it because a lot of the logic that you're going to use is still going to be reusable once we implement that feature directly into MetaMask. Another reason why I would say that it's worth it is because you're going to be one of the first to be doing this, right? So once we do have account abstraction available inside the accounts API, a lot of eyes are going to be on you because you're going to be at the forefront. You're going to be developing something that nobody has developed before. So I would say it's worth it, and if you're doing it especially for the hackathon, that's going to impress the judges. So 3 things that would tell me that it's worth it. Question. This bounty is for the ETHGlobal Istanbul hackathon. At every hackathon, we have different kinds of bounties, but this one is for this hackathon. All right. And the second bounty, I have 5 minutes. The second bounty is not about building a snap. We have a lot of snaps already available, like I mentioned, on snaps.metamask.io, and a lot of them are interoperable. They're composable, right? You can create a dApp that uses an existing snap. Like we have a Masca snap for creating decentralized identities. We have the Starknet snap, Solana snap, and you can build a dApp that is using one of these snaps. All your dApp needs to do is install the snap, just like you have in the example dApp, and then you can start building a dApp that's doing, NFTs, DeFi, that's using Solana or whatever, and you can use one of those snaps to do that. And you can win $5,000 if you are able to impress us with such a bounty. I have a list of all the snaps here that are useful to build upon, and there's a lot of them. And they're also listed in the official bounty text on the ETHGlobal Istanbul website. Question?
Yeah, last time I checked, there was a security feature that you cannot deviate the Ethereum address.
That's correct. So the question is a snap I showed earlier is able to derive private keys. You can derive Bitcoin keys from the seed phrase of the user and all that, but we do not allow derivation of Ethereum keys, right? Ethereum is coin type number 60 in the SLIP 44 specification, and we don't allow that because that would be deriving the same keys as MetaMask, and for the moment we deem that to be a security issue. So unfortunately, you're not allowed to derive keys for coin type 60.
What's the pattern?
Pardon?
What's the pattern? You create a new public address for the user then and show this is your address from now on?
Yeah, pretty much. That's exactly what you would do. You would create a new address and show them that this is your public key. They can export their private key if they want to. And I don't have a lot of time left. I will be available later if you have more questions. But there's a bunch of resources. I'm not going to go through them. There's videos. There's links. I will put the QR code again if you want to see it, so you can go to them. At ZiadMTL is my Telegram, and I showed you earlier the Telegram chat for us. Yes, this QR code. And what else? Okay, so we have a bunch of other bounties, right? Consensus is a big company. We have a lot of products available. One of them is the MetaMask SDK, which allows you as a developer to put up a QR code for the user so that they can connect their MetaMask mobile to your dApp very easily and with a very, very fast connection. It's actually a little bit better than using Wallet Connect. And we have a $5,000 bounty where all you have to do is use the MetaMask SDK inside of your dApp. And the last one is a Linea bounty, right? Linea is a EVM compatible layer 2 for Ethereum. And you have $5,000 bounty. All you need to do is deploy your dApp on Linea, okay? You can deploy it on any other L2, I don't care. But if you deploy it on Linea, you can be part of our bounty, right? The fact that it's an easy bounty means that you're going to have to impress us with the quality of your project, obviously. And all of our team is going to be available to help you with that. We have Colin, our director, who's wearing the blue hat in the back. That's Colin. And Eric is not here. We have Lauren, who's sitting right here. And there's me also. My name is Ziad. And our booth, okay, is like the easiest to notice because it's the biggest and brightest and shiniest booth. It has a big TV. And it's all the way in the corner in the back of the hacking area. So you come to see us if you want to chat, if you want to talk about bounties, about L2s, about anything you want related to Web3 or not Web3. And we'll be happy to give you some swag and to talk to you. And I want to thank you very much for being here with us today. Happy hacking and have a good time. Hello, hello. Thank you. Cheers. It's your turn. Yeah.
Thank you.
You have 30 minutes.
Yeah.
Try to leave 5 for questions.
Okay.
Usually I have a feeling track and then you have like 3 more minutes or something like that. Because otherwise I have to make science.
Yeah. You're good.
Yeah, and if someone asks a question, please repeat it in the microphone for the stream to the other people to hear it as well.
Yep.
Whenever you're good to go.
All right, can you see that? No? Oh my God. Light mode? All right. We'll go with light mode. We'll go ahead and get started. Hi, everybody. My name's Nick. I am here from ZK Sync, and I'm going to be talking about the in-memory node for testing and local debugging whenever you're deploying your apps to ZK Sync. We'll go through quickly an agenda today of what it is, but some background about myself. I've been a software engineer for 12 plus years. Recently joined the Matter Labs company, came from SpaceX, and yeah, let's get into it. So before I go into Era Test Node, I do want to cover what it is we could be using for testing today. Sorry if it's like a dark background, a little difficult to see. I'll just read it out loud sometimes. The first option is we have a public testnet, right? It has Goerli as the L1, and the downside of this testnet is it's difficult to find funds from a faucet. The second setup is having a full local Dockerized network using 3 Docker containers, and we have that available in this GitHub repo that I have listed below at local-setup. So it is just a local network from a layer 2 down to the layer 1 with a Postgres database. It takes a few minutes to get set up, and these are 2 great resources to get tested your smart contract locally. But let's talk about Era Test Node. So we wanted to build something that improves a lot of the problems and frustrations that people were having whenever they were developing for ZK Sync. So one, it needed to start up fast. So for Era Test Node, it starts up in less than half a second. The ability to fork the upstream mainnet and testnet networks at any given height. We want to be able to replay transactions from these networks. We want to give you these pre-configured rich accounts so that if you were to start it up locally, you don't have to worry about finding a faucet somewhere so that you could start just deploying and using your smart contracts. Support for getting the console logs for Hard Hat or Foundry. The call stack should just be easily available to you for debugging purposes. And if you're having any issues with gas utilization or just questions about why is it so expensive for your smart contract, we wanted to make it really easy to dig into those gas details. So what does it look like to run the ERA test node? So first and foremost, it's a binary. The one way you can run it is download the binary from our GitHub release, and the command would just be ERA test node run, and it'll be up and running on port 8011. The second way is you could actually just use npx. So this npm tool, we have a zk-sync CLI tool where you can just say dev start, and you don't have to download the binary manually. It will just take care of that for you and get it running. Finally, the last way to do it is to have it embedded in your hard hat configuration. So if you add this yarn package or this npm package of Matter Labs hard hat zk-sync node, then in your hard hat config, you add the import statement that I have at the bottom of that exact package. Whenever you do things like npm hard hat test, it will just run against that local node, spin it up for you, download it for you, and stop it whenever you're done running your tests. We'll go into some examples about that later. But why did I give you that background, and how do these three different approaches compare? So just a quick high overview, you have a comparison between the testnet, those Docker containers, and finally the ERA test node. So running locally, the testnet does not do that. It is not running on the public servers that we have, and this could be a downside. If you are running your tests in CI/CD, sometimes you don't want to rely on a bad internet connection. If you want to develop fully offline, you're on an airplane, you want to be able to develop everything locally. Rich accounts, so testnet, right? The downside is you have to find go early ETH. You have to find a faucet that you trust to get some, tokens so you can actually use your smart contracts. In terms of fast setup, the testnet is live. You don't have to do anything. It just works right now. However, the downside for something like Docker is it takes 5 to 10 minutes sometimes to get running for the first time. And then debugging. You don't get debugging with any of the other approaches like you do with ERA test node. So in terms of configuration for some of these, the chain IDs are different, 280, 270, 260. Obviously, the endpoints are different, but the major difference is layer 1. ERA test node does not have that layer 1 component. It is just a layer 2 in-memory node, similar to like the hard hat network node or Reth, or Anvil is another example, and it doesn't require or doesn't have that capability to communicate to an L1 at the moment. So if you need to test that functionality, go with one of the other options. I've been talking about it a lot, but let's go into a quick demo of how would we deploy a greeter contract. Let's talk about what you would need to add to your hard hat config, and really it's just a network with the URL pointed to localhost port 8011. So let's take a look at that. I have created a template project based off of zk-sync CLI template, or create, sorry. And what I was talking about with the greeter contract is right here. We have a string that we are setting in the constructor, and we have two methods where we get this greeting message and we set the greeting message. So what we can do is go ahead and start up the ERA test node run, and there you go, it's already running. So what we can do is actually start using it, and it will be here. Let me toggle presentation mode real quick. That way you can see a little better. All right, so npm run deploy. And for the network, I'm going to say in-memory node. So you'll see the first thing it's saying is it doesn't have a private key. You need a wallet to be able to deploy. But the nice thing about running the ERA test node is it spits out that information for you right at the beginning. It tells you what the chain ID is, it tells you what port it's running on, and it tells you what those 10 rich wallets are that you could use locally. So in the .env file, I'm just going to paste that in, run it again, and let me scroll down so you can see it. So it deployed, and you can see if I scroll up, that here is a summary of the transaction that happened. In the lower command line, you will see that this is the contract address for the new greeter contract. Here are the constructor arguments. And in-memory node, you see this was the transaction. It was successful. You can see who initiated it, who the payer was, what gas was used, what gas was refunded, what some of the events were, and it will still keep running, ready for the next command. So let's get into that next command, which is we have the ability to interact with this new deployed contract. And what this script does is points to this greeter contract that we just deployed. It gets the greeter message, it sets the greeting message to hello, I'm just gonna say dev connect, and then gets it one last time. So let's do, instead of deploy, interact. And you'll see, if I scroll up over here, that there was a call, there was a transaction, and that's to set the message, and then there's another call to get it one last time. And in this project, we also have hard hat tests, right? So that whole workflow that I just showed you of deploying the contract, setting it, getting it, updating its value, and it can all just be wrapped up into a single test, and it will work. Now, let's run this. Sorry, 1 second. All right. Let's skip that for right now. I don't know what the error is. It looks like it's hitting an API rate limiting for an unknown reason. That's probably because the internet connection for me is really not great down here. But you can easily point to the hard hat node, but you'll notice that it won't actually be outputting the content to the node that is running in this console. And the reason is because whenever you are just doing hard hat tests, it is using the hard hat network. And this was that third example of how you could run it locally whenever you're running tests, where we say, okay, import this node, and so whenever you do hard hat tests, it will just start up a node in the background, run against it, and spin it down whenever you're done. So it's great for CI, and you don't really have to take care of or worry about too much. So just as a small recap, I showed you how to start this in-memory node, deploy a contract, use some rich accounts, execute the contract, and hopefully run some automated tests. Now, I have shown you just a basic node, like a hard hat node, but what we really wanted to do is make sure that you could actually debug some of your transactions. And what do we need to support whenever we want to have that capability for developers? The first two things are we want to show you the call stacks, and we want to show you the console logs. So whenever we're looking at a bunch of tests or debugging, it's just console log everywhere. It's console log for hard hat, it's console log for Foundry. So let's look at showing that exact value. So over here, what we're going to do is update the greeter contract. So when I say console log, that is this console log. That is the hard hat console, and I have two new console log statements at the beginning of set greeting. So set greeting is called, and then the value that was passed in. I also added a check right underneath that says, hey, make sure that the greeting value that you're trying to set it to is not equal to the string test. If it is, go ahead and revert and say received a test value. We don't want that. So we're going to compile the contracts again. And then we'll redeploy. I'm going to take the new address, update the interact contract. And this time, when we interact, let's take a look over here at the era test node. So as that ran, if we look up, right here in the transaction, we can see the console logs are being spit out right inside of the transaction summary. The call traces are here. It says there are 20 of them, but you don't see them. We hide them by default, but we can easily show them. So while this node is running, we've added a bunch of APIs so that you can update the settings about it. You can update the log levels. You can update information about how much show call information you want to see, etc. So we're going to call config_set show calls while the node is running, and we're going to set it to all. So let's do the interact script one more time. And this time, you'll see a lot more information. All of the stack traces showing up here, and you'll see it is indexed based off of the tree index for the entire call stack. So if you go in here, you'll start seeing things like the console log statements, the two that are right here, the two cacac statements that you are using to compare that your string does not equal test, etc. But you can't really necessarily read all of the information easily, so we have another method to do that. And if you scroll down a little bit, set resolve hashes. So what we're going to do, if we run this one more time, is you should notice that these values on the right are no longer just hashes. We reach out to OpenChain API, turn these values into human readable functions so that as you're going through the code and you look through, you see, oh, whenever I called set greeting, before that, it did execute transaction, set transaction origin, get raw code hash. All of these methods through the entire system are available to you. So, I need to show you what an error looks like. So I had added that check that says, hey, the value shouldn't be test. So what happens if we do set it to test? Can you easily tell what's going on? And boom, right here. In bright red, it already tells you, look, execution reverted, received a test value. This is insanely useful whenever you are trying to debug a set of transactions inside of a batch. It just highlights exactly what the problem is, and you don't have to dig any further to resolve the issue. So in terms of console log, call stacks, readable events and ABI functions, easily spotting errors and reverts, that is just like first-class citizen for the in-memory node. Now, the other nice thing about debugging is we want to be able to give you the ability to fork mainnet, fork testnet in a few seconds, and also replay transactions. So why would you want to replay a transaction? Well, let's talk about a scenario where a customer says, hey, within our tests, everything worked, but ZK Sync has an issue. When some transactions fail with an error message, this is a long bunch of texts. Here's the contract address. I tested it myself with the same result. If you need anything, please let us know. And we don't have access to their console. We don't see what they're seeing. We're just hoping that they give us the information they need, but we don't have to do that. We know exactly what the transaction is. So if we were to click on this and open it in the block explorer, we can see the first hash, like yes, it failed, right? But we can take this transaction hash, and if we go back here, we can actually use a new method called replay_tx, replay the transaction, against testnet, and we give it the hash of the transaction. You'll notice that I already showed you show calls, resolve hashes, but I added a third one in here, which is show gas details. They want to be able to see what was happening with the gas cost. Why is this thing using up so much gas? Or we thought that was the problem. So we took a closer look. And if we take this and make this as large as possible, I'll stop the node. So I run the command of replaying this exact transaction. Inside of here, you'll see that there were 2 transactions in this batch. So it gets each transaction. So it's already forked testnet, by the way. It happened that fast. But what it's doing is it's taking those 2 transactions and it's replaying them one after another locally. Now, it's also reaching out for every single one of these methods and getting the human readable function names that you see on the right. So the events are also being translated, so you can see the transfer events, etc. Right here, you see the big bright red error, which is whenever they were calling set latest answer, it threw a panic. If we scroll up a little further, there is a new section inside of the transaction summary. There is a massive gas details section, and let's take a look at what it does. Well, one, it breaks down your gas usage by transaction setup. You'll see 25% of it went to transaction setup. 64% went to account validation. 9% was spent on opcodes. And if you break down the transaction setup even further, you see 93% was spent on operator costs. If you keep digging, there are these overheads that we give you insight into. So all of this gives you the right tools to be able to dig down even further, and you can literally just replay transactions that are giving you problems in testnet and mainnet. And if you notice, if I scroll all the way down, this node is still running. You can still execute transactions against this. You can still use this because it's still running and it's forked at that exact moment in time with the error that you just saw. So if you want to dig in further, you can. It's still live. Now, forking, you don't just have to fork, at the latest block. You can fork at an exact block height, right? You can fork testnet, you can fork mainnet. Whatever you need to do for your local testing, it should just work. So I talked about forking mainnet, testnet, forking at a specific height, replaying transactions, and digging deeper into some of those gas details to figure out why something is so expensive. In terms of CI/CD, we wanted to make it easy so that this in-memory node, yes?
Yeah, just a quick question about forking. So it's basically replicating the state at some particular time.
Yes.
That you choose, and then you fork and continue from there, right?
Yeah. So in terms of integrating it with your CI/CD, one way is just the GitHub action. If you just need a node running that you want to point something to it, it's this bottom part right here. You just say, /era test node action at v1, and it's running. It starts up on port 8011. You can give it the extra parameters if you always want it to fork from a very specific block in testnet for your CI/CD, whatever the case may be. In terms of what's happening next and what do we want to see with a tool like this, so one, support for Foundry. We want to have things like Forge, Anvil, Rivet, all these things just sort of work in a very quick and fast environment that you can manipulate a lot of the underlying information. When it comes to the node itself, you should be able to do what you need to test all of your smart contract from beginning to end. The project itself was open source from the beginning, so if anyone wants to contribute to it, we are encouraging the growth of that open source contributions for the project. Adding the ability to connect to an L1, right now it's just an L2 on its own, but there's nothing, there's just some work involved that's necessary to get it connected to an L1 so that you can test the full beginning to end. Support for more APIs, and then what else you can think of. So this is all written in Rust. If you want to take this in-memory node, compile it down in WASM, now it's JavaScript, you could have an in-memory node running in your browser. You could have, theoretically, an in-memory node that is right next to the transaction that fails in your block explorer in Etherscan. And you say, oh, why did it fail? And then it just replays it based off of forking at that exact place, tells you exactly all the details that you need to see, and you can just investigate right in the browser. So that's one idea that you could do. Yeah, we have GitHub discussions, and I'll make sure to circulate the slides through ETHGlobal. But one other project that we did this week, I know it's over, but ZK Quest was something that we had published this week, where we basically built a little capture the flag video game for this week, and all of the development was against local ERA in-memory node. So it was a true battle test of like, this thing works. We've used it for doing a bunch of experiments in the company where we can manipulate and change the underlying system contracts for the ZK Sync era node, and validate that, oh, future changes are going to work. We're changing the prover, the underlying prover, and we know it's going to work because it works for the in-memory node. We know that we can make some drastic changes to the underlying system before pushing it out for the public to use, because we have this in-memory node. So yeah, any questions? I know I kind of sped through it a little fast just because I'm only, yes?
Yeah, so like, I didn't get that with the Foundry slide, you were proposing to like build for support with Foundry, or it exists for it?
No, so we'd have to, basically the way Foundry is built is around Anvil, right? That is their like in-memory node. The thing is, it's built specifically, just for EVM, similar to like the Hard Hat network node. But what we want is, because ZK Sync has the ZK EVM, which is EVM compliant, we actually need to tie it into this in-memory node that we've built. We need to have a wrapper around it. If we build this wrapper so that these tools think that it is Anvil, then everything will just work, from Forge to Rivet to other just like Foundry tools that they're building around having an Anvil-like sort of in-memory node. So same thing for Hard Hat, right? Hard Hat has a network node that it starts up whenever it runs tests. If we just wrap the in-memory node that we have to look like and have the interfaces of that network node, then it'll just be plug and play and it should just work. And so that's sort of the idea here. Hopefully that answers your question a little bit.
Yeah. So like right now with Foundry, I can't really go and interact with any of the test nets?
For ZK Sync, not at the moment. That's something we're working on right now, where, yeah, we're working on ZK Forge, and then...
Oh, sorry. You said it's due to the fact that it's ZK EVM?
Also, it's EVM compliance, and then also the ZK underlying EVM. Yeah, there are just differences that are not exactly supported from Foundry. They haven't had to. Same, like, there's a lot of Foundry that we're working with them so that we can actually build a standard so that it can support different types of EVMs. Cool. Anything else? I know I wanted to leave some time for questions, so. Nope. Yay. Thank you. All right.
Yeah. All right. Here. Okay, thanks. Oh, okay. Maybe on split it? Light mode. Because we don't. If you have code. Yeah. And maybe a bit Oh shit. Otherwise, maybe make it bigger. I just broke my presentation. Wait. I need a moment because my printer just broke it. Okay. Okay. This. All right. Just switch it to light mode now, and I'll just deal with this. Shall we start it? Hello? All right. Hello, everyone. Welcome to Introduction to ProtoKit, aka the Mina protocol presentation on how to build ZK rollups. My name is Matej. I'm the one of the co-founding engineers behind ProtoKit, and today I would like to show you how you can build your own ZK rollup with little to no learning curve on the Mina protocol. You can see our socials right here. So if you have any questions, please write them down and ask them afterwards, because I have quite a lot of content to go through. So let's get started. Before we get to the actual ZK rollup building section, I want to make sure that we are all on the same page when it comes to understanding of what zero knowledge actually is. So let's get into it. So the first question I want to answer is, what is a ZK proof? So ZK proof is a mathematical proof of computation that is done on top of using like public or private inputs, and it results into a public output. What can you do in a proof of computation? So you can verify signatures, you can verify Merkle proofs, you can do addition, subtraction, multiplication, or for example, hashing using Poseidon, and a lot of other cool stuff that can be mathematically proven. To compute a ZK proof, you need to use a proof system. The proof system that we use for ProtoKit is called Kimchi, and is the same proof system as the Mina L1 is based on. To generate the proof, you need to execute something that's called a circuit, and the thing that we'll be looking at the next slide is a ZK DSL written in TypeScript called O1JS that allows you to write circuits in TypeScript, which you can then compile and generate a proof of the computation that you have defined. So when you compile a circuit, you actually get two artifacts. So you get a prover key and a verification key. We'll see that later, and how it ties into building your own ZK rollup. The most important part of why you should even care about proving your execution is that it allows you to run the execution once, generate a proof, and then anybody who wants to verify the result of that computation can cheaply verify the result without having to recompute the expensive computation again. So this will be very important when you, for example, try to design a blockchain with a consensus mechanism where all the validators have to revalidate transactions when they're, for example, bootstrapping or simply participating in a network. With a ZK proof, they don't have to rerun the transactions again. They just have to validate the proof of applying the transactions by the person who created the block. So the zero knowledgeness of a proof comes from the fact that the computation can be done on two kinds of inputs. One is public, or it could be also private. So when the verifier is verifying your proof, they have no access to your private inputs, only to the public results of the execution. I've already mentioned O1.js. So O1.js is a TypeScript library that allows you to write circuits. There are a couple of important primitives exposed. It's called, for example, ZK program. As you can see, we start with defining the inputs and the output types of the program, and then methods, which are the actual computation that we care about. Every method can have its own private inputs, and the following program is very simple. It's basically a program that proves a transition from one counter to another counter. And it only allows you to perform the transition from a hash of a number to another hash of a number if you know the preimage of the hash, right? So just to go quickly through it, line number 10, we are hashing a private input A, which is a uint64. Then we are ensuring that the hash that we have created from the private input of the number matches the public input of the number, which is the current state, the current hash of the counter. Then we increment the raw number, so A plus B, that's line number 12. And then we return the new state, which is the hash of the addition that we have performed. So we have a hashed counter, and we prove that we know the current value of the counter and transition the state to a new hash of the counter. So how do we run the circuit? So first you have to compile it, as I've said. That gives you a prover and a verifier key. The compilation itself is pretty expensive. So depending on your hardware, we are talking at least like tens of seconds. Then we define some state variables that we will feed into the increment method. And line number 7, we actually run the increment method of the circuit. This is another expensive part because you actually have to mathematically compute the proof behind all of the operations that you're trying to do. So you can expect another like tens of seconds to actually generate the proof. Then we get a result, which is our proof of increment. That proof can be verified very cheaply using the verification key. We see that at line number 13. And then in between, we can just keep track of the state variables that we need to. So very simple. We've just written a counter circuit. We've seen how to compile it, how to run it to get a proof, and how to also verify the proof. Another important aspect of the Kimchi proof system, or actually the recursion layer on top of the Kimchi proof system, which is called Pickles, is that all of these programs and all of these proofs can also be recursive. So you can write a bunch of ZK programs, and they can compose with each other, right? So this allows, for example, for effective parallelization of your chain. So later we'll see how to write the ZK rollup, and we'll go through like what actually happens behind the scenes, and we'll see how we split the execution into multiple parallel proofs so we can have increased efficiency using recursion. Recursion essentially means that the mathematical logic that's required to verify a proof is implemented in the circuit itself, and that's pretty much it. So how is this helpful for blockchains? What is a blockchain? Like, that's the first question we need to understand. It's basically a distributed database with a consensus on the latest state. So nodes execute user transactions, and a transaction is just an authorized intent to perform some state transition on top of the current chain data. That's like every blockchain out there, it's applicable. So after a block producer runs all the transactions on the behalf of the user, the transactions are then bundled into a block, and the block then signifies the new state of the blockchain. So if you want to verify that the block and all the transactions in it are valid, for example, on Ethereum or on any other non-ZK chain, you have to rerun all the transactions. This is super expensive, and it means that you have pretty significant hardware requirements to be able to do that. You need to store all of the data of the chain, and you need to have like a beefy CPU to rerun the transactions. So as I said, high hardware requirements, which means lower decentralization. So what Mina does differently as an L1, so the entire protocol is like written using zero-knowledge circuits. So it means that whoever's participating in the Mina network, once a block is produced and it arrives into your node or into your light client, you don't have to rerun all the transactions again. You just verify the block proof, and you can be 100% certain that the person who produced the block did everything that they should have done correctly, and they didn't try to cheat by, let's say, double spending or other common attack vectors. So thanks to Mina's recursive proof design, a block is a simple recursive block proof, which means that the blocks can be verified cheaply and quickly without rerunning the transactions. So let's now talk about Mina's native L1 smart contracts and how they tie into the recursive proof design of the L1 protocol. So smart contracts on Mina, you have to write them using the L1JS library. There's a primitive called smart contract. Smart contract is just a circuit, like the ZK program we have seen before, that runs on your client, so literally in your browser, and proves its own execution. So you don't need a block producer to run the contract anymore because you run it on the client side. This means that like the blockchain can effectively scale pretty well because you don't have to do all the computation on the node side, but all the users do it for themselves. That is a pretty significant leap forward, I think, when it comes to design of blockchain. So they're executed off-chain, as I said, on your client. The node operators don't have to execute them. And what this means is that if you run the smart contract off-chain, so you run the contract on your device, the only thing that you have to send in the transaction to the L1 itself is a list of state transitions that you want to apply to the global chain state. In the concept of the L1, those are called account updates. The account updates are then authorized by the proof of execution of the contract, or they can be also authorized by a signature, but that's less interesting. Then the block producer only verifies the proof of execution of the contract and applies the changes to the chain state that need to happen on the L1. After the block producer applies all of these account updates or the state transitions, you end up having a new block which has a new global chain state. Those were the good parts, but now we'll talk about a bit more about the, let's say, the design limitations of this approach. Basically, if you have two clients, or like everybody in the room would try to do a transaction to the same smart contract, and they would be using what we call preconditions, which we'll explain later, they would essentially run into a race condition where they try to update the same state, but the proof was calculated on outdated state. So it's like a race condition. All right, here we have the same circuit as we had for the ZK program, but now it's written as a smart contract. So the first thing that we see is we define what kind of on-chain state do we want to store. So that's line number 3. Smart contracts allow us to store 8 fields worth of data on-chain itself. That's about 8 times 255-ish bits of data on-chain. This is a pretty severe limitation that we have to engineer around, and we'll learn how to do that later. Again, we have to define a method to interact with the state of the program or the smart contract, and again, it's an increment that increments the counter or the commitment to the public state only if we know the pre-image of the number. The most important part here is line number 9, where so line number 8, we fetch the on-chain state by doing this commitment get. And then line number 9, we are doing an assertion in the proof itself that results into a transaction precondition, which tells the block producer that, hey, I have done this proof, and it was done using this on-chain state, because the on-chain state becomes the public input. And this is where the race conditions come from. If multiple users are running the off-chain proofs in parallel on their devices, and they use the same preconditions, only one of them will end up having a valid transaction because the second one will get invalidated through the precondition or the commitment to the on-chain state. This is how you can send transactions to smart contracts on Mina. It's super, super simple. So you just need to know the address of your deployed contract. Then you send the transaction specifying the fee payer. You execute the method with the inputs that you want. And then you'll have to prove the transaction and send it. As we can see, running the increment method on the counter results into several account updates. And the account updates looks simply as follows. So there you have the address, then the preconditions to the on-chain state, and then state updates since you are updating the on-chain state, plus, of course, the proof authorization. This is like a pretty straightforward diagram, I believe, of how the smart contract layer looks like. So at the bottom, you have what happens on the client. At the top, you have what happens on the network or on the node. So let's start from the left. Alice executes counter.increment that gives us an array of account updates, which are authorized by approve and then sent to the network. So once the list of the account updates gets sent to the network, what the block producer does, it iterates over all the account updates, tries to verify the proof attached with every account update. If it's valid, then it also checks the preconditions. And if all of these things end up being true, then it applies the account updates to the state. So therefore, you have a transition from the initial state to the resulting state on the L1. Now, let's talk about circumventing the storage limitation of 8 fields in the smart contracts. So the reason why the limitation exists in the first place is because when you write zero-knowledge circuits, they have this property which we call they have to be fixed size. So it means that you cannot have dynamic size arrays because what a circuit is essentially just the trace of execution, and the trace of execution needs to be the same at compilation time and execution time. So if your input size changes, therefore your trace changes as well. So because the trace needs to be fixed or static size, the storage which you can work with needs to be fixed size as well. So what can we do about this? So first of all, you cannot have like key value storage like this because that would be dynamic size. You cannot have a storage of a public key to Unix64 like you would have in an ERC20 contract to store balances. However, what you can do is you can start using Merkle trees and store only the root hash of the Merkle tree in the smart contract's public storage. So let's go through what is a Merkle tree. So Merkle tree is a cryptographical data structure that allows you to verify that certain data is part of a larger data set. And you can do that using Merkle tree witnesses. So if we apply this concept and we take a Merkle tree and start using it within our smart contract proofs, we can circumvent the storage limitation of the 8 fields, and we can have essentially infinite state as long as it fits into our Merkle tree. So if the tree is tall enough, we can have essentially unlimited state. So instead of storing counters for every users, we can store a commitment to the tree of the data that we're working with. And then the increment method of the counter would have to get the commitment, therefore the root of the tree. It would have to verify that the data we're working with, the actual counter, is part of the tree, and then write the changes to the tree itself by updating the root hash of the tree and storing the root hash on chain again. So this is how you would actually like update the Merkle tree. You would have to add the numbers together as we've done before, and then you would have to compute the root hash of the Merkle tree by using the new counter value. So pretty straightforward. Now, we have to go back to the design limitations of preconditions we were discussing before. So since now everybody is working with the same Merkle tree of data, they have to work with the same root hash of data. So if there are 2 clients computing something or trying to update the data concurrently, only one of their transactions will be valid because the second one will get invalidated due to preconditions. So again, preconditions pointing to the root hash of the tree causes issues. To users transferring causes issues. There we go. And that's a diagram basically showcasing the precondition interaction. So we have Alice that's trying to execute counter.increment, some off-chain storage component which stores the entire tree and the actual data, provides the data for Alice to do the computation in her proof. That gives her account updates, which tries to set the counters to a new root hash or new state, but it also has preconditions to the previous state because we were reading the existing counters of the users. So those were like the good parts and the bad parts of the L1 smart contracts. Me and my team, Rafael, who's sitting in the crowd there, we wrote a library that basically allows you to write your own ZK rollup where you won't have any of these concurrency issues, state limitations, or anything of that nature. It's very simple to get started with the library. You just have to like clone the starter kit and read the README, obviously. So what is ProtoKit? ProtoKit is a TypeScript-based framework for building ZK chains. It's not using another ZK VM. Instead, it uses a very custom, usage-specific ZK VM. It has a hybrid execution model, which means that you can have both off-chain execution and on-chain execution. Therefore, you get all the benefits of the L1 smart contracts plus custom on-chain behavior. Off-chain execution means that you can do client-side ZK proofs. Therefore, all of the rollups are privacy capable or privacy enabled. The execution of the protocol that powers your ZK rollup is end-to-end proven, same as the L1. So therefore, if there's a centralized sequencer that's running the protocol for you, you don't have to be worried about the sequencer being malicious because all of the execution is proven exactly as it should be. The framework itself is very customizable. We try to write it in a way that doesn't force people to use certain libraries or certain techniques. So if you don't like the RPC library we created, you can just plug in your own, which makes it very flexible. I think that the framework has virtually no learning curve, assuming that you've built with the smart contracts before, or at least you have some TypeScript knowledge or existing Solidity knowledge. So should be pretty easy to get started and get building, which is important for a hackathon. So let's build your own ZK rollup. So recursive ZK rollup is again just a series of recursive ZK circuits. We've seen ZK program before. ZK rollup is just a lot of ZK programs, and we provide the interface to make it as simple as possible for you, so you can focus on building your app instead of building infrastructure. Every user transaction in the rollup is essentially running a ZK program that results in state transitions, same as the account updates, and we prove all of that for you. If you want to do this on the L1 with the smart contracts, there are some built-in primitives for like sequencing or like mempool management, but you still have to write your own circuits. So with ProtoKit, you can build zero-knowledge, interoperable, and privacy-preserving application chains or ZK rollups with like no learning curve. You can roll your own ZK rollup in a few lines of code. And one thing that I want to mention is that if you write a ZK rollup, not a ZK app or the L1 smart contract, it's going to be a superset of what's possible with the L1 smart contract. So you will preserve all the privacy features of off-chain execution and have new features thanks to on-chain execution. Let's talk about a bit more about what the ZK rollups are made of. So we have the runtime, which is replication logic. We have the protocol, which is the underlying VM that handles the circuits for block production, transaction fees, etc. And then we have the sequencer, which contains modules for like the mempool, orchestrating the block production, or settling your rollup to the L1. All right. So what kind of features can you expect? We're hoping for like a supercharged developer experience, but like that's for you to tell us what you think. You can use like a bunch of reusable modules, so it's super easy to create a composable ecosystem where you just use npm install to install, for example, a runtime module. You won't have any data race conditions thanks to the fact that we have a sequencer which will sequence the transactions on chain on your behalf. You will have bottomless on-chain storage, not just 8 fields. You are still able to preserve privacy or anonymity thanks to the fact that we have the hybrid execution model. You don't have to focus on infrastructure. Instead, you can focus on building your business logic. It works well with the established ecosystem wallets, and it's not another ZK VM. And if you wanted to, you could re-implement the entire L1 smart contract backend in the framework itself, which is not something I would encourage you to do because it's pretty complex, but like if you wanted to, you could. You can add features that will be executed on chain much quicker than the L1 will because it's application specific. And some of the more things, like some of the additional things that we're working on is interoperability between all of these rollups because you don't want to have liquidity fragmentation or like siloed rollups, and also data availability. And these two topics pretty much come hand in hand and are pretty important for like further decentralization of the rollups. So how does the lifecycle look like for a ProtoKit rollup and a user transaction? So at the bottom left, we have again Alice. She creates a transaction where she wants to transfer some balances. She doesn't have to prove anything, so therefore it won't take her several tens of seconds on the client side. Instead, she does a simple signature and sends the transaction to the rollup operator itself. Then the roll operator sequences all the transactions received from the user and executes them one by one, proving the execution of every individual transaction and also proving all of the state transitions that resulted from the transactions. This results into a block proof. That block proof is then taken and settled using L1 smart contracts to the L1. Writing your own runtime for your own ZK rollup is relatively straightforward. It's essentially the same developer experience that you get from the L1 smart contracts, but you have more on-chain storage and you have on-chain execution. So this is, for example, how you would write a simple ERC20-like module with the ability to transfer balances from one account to another. Testing your ZK rollup is also super simple. We offer something called the starter kit, which I've already mentioned. You basically have to create your testing app chain from a runtime object, so pass in your balances class, start the app chain, and continue like writing your tests. In the tests, you would obviously have to execute the transaction, so the API is nearly identical to what you can expect from the L1 smart contracts. That was actually like one of the design goals, to take all of the smart contract developers from the L1 and allow them to transition to ZK rollups with no learning curve. So you sign a transaction, you send it to the chain, then you manually produce a block in your tests because you can have control over that, and then you can read the resulting state of the transaction using our query API, which returns you the new state. So if you want to start hacking on Mina and you want to build your own ZK rollup, all you have to do is clone our starter kit, install the dependencies, start a sequencer that will start the example runtimes packaged into the starter kit. Plus, you will also have to start the UI and get building. The starter kit is pretty opinionated. It has a React/Tailwind/chat-CDN based UI. And it showcases how you can connect to the chain, how you can read state through our GraphQL APIs, how you can send transactions, and how you can connect to your browser wallet. So all of that is ready for you to start hacking. You just have to pick it up and get to work. All right. So what are we working on now? So we've built a bunch of tooling, obviously, for ZK rollups. Now we are kind of like transitioning, not stopping working on the tooling, but we're also focusing on the product side of things. So we're building like an open treasury/governance system for the Mina ecosystem itself, or like for every ZK rollup built with the ProtoKit tooling. We've also built a DEX called Copang. It's built using ProtoKit. You can check it out. It's a nice demo that runs in the browser completely. Even the sequencer itself and the whole chain runs in the browser. Find it on Twitter, check it out. Let us know what you think. The question is, what would we like to see as, let's say, judges or developers of ProtoKit? We would like you to work on the following things or any other ideas that you can bring to the table. We'll be here for the rest of the weekend to help you build. So the things that I'm personally excited about is things like NFT standards, stablecoins, lending markets, dispute resolution, credentials, name services, or anything else that you can see in other ecosystems, and we pretty much don't have it yet. You can find our website at protokit.dev. All the links to GitHub, Starter Kit, our Discord server where you can ask questions are there. I would like to wish you all good luck and have fun. And let's not forget about the fact that Mina Protocol has put out a pretty chunky prize pool of 20K. So come and build. Thank you. Any questions? No one? Okay. Yes?
You mentioned the race condition.
Mm-hmm.
So, with the Muckle tree, still we are updating the Muckle root, right?
Yeah.
How does it solve the race condition?
Yeah, so the difference is that with the smart contracts, you have to do all of the computation in your browser as a client. But the difference here is that the sequencer does it for you. So the sequencer separates the execution and then sequentially builds the Merkle root and applies all the state changes. That is the main difference, pretty much. All right. Thanks. Here? All right.
can I connect? Yeah, thank you.
You have 30 minutes. Try to give 5 questions if you can. Whenever there will be like a few minutes left, like 2, 3, I'll be here in front so you know time up. If someone asks a question, please repeat it in the microphone so it hears on the stream.
Okay.
For the rest,
It's working?
I have a question. I really want to connect this technology to games because I think it's very useful for game when player just plays, generate some proof and some proof.
Actually,
Maybe you tried something.
I think it's related to the previous speaker. Like I'm from one inch.
Previous speaker, I think you can find outside. Or they have also the booth, it's called the Mina.
Can we wait for the audience? I'm ready. So do I need to wait for the audience or can I start? Okay, good. So, hello everyone. My name is Kirill. I'm the backend team lead in 1inch, where we actually build the future of decentralized trading experience. Today, I'm going to talk about how we came up with an idea to build 1inch Fusion, which problems it solves, and how it actually works. And also we will dive a bit into the history of decentralized exchanges. In the distant years, DeFi was born with the appearance of first AMMs. And since then, the DeFi market has grown about 70 times. And we built a lot of cool projects, the combination of these projects to build the DeFi even more efficient than the centralized exchanges. The first step in DeFi world was DEXs, like AMMs. Developers decided to create some formula on a smart contract that allows to provide liquidity with 2 tokens and swap 1 token to another. So, but there was a problem. At the beginning, it was about 5 DEXs, and you need to find the best one. So what I can do, I can open several tabs in the browser, and at the same moment look at all exchanges and try to compare exchange rates and also transaction costs, because each DEX has their own computation, and you need to pay gas for this computation. This is how actually 1inch aggregation protocol was born in the hackathon in 2019. It was the ETHGlobal Istanbul New York hackathon. And actually, what is an aggregator? Aggregator allows to execute the transaction atomically by aggregating between different automated market makers, private market makers, and also limit orders. The path just built through several exchanges. You can split the entire token amount into several DEXs, and even you can use connector tokens to catch the deepest liquidity. But anyway, there is a problem. With the aggregators, as a user, I need to fight with MEV bots, because MEV bots can front-run your transaction, they can sandwich you, and for the ordinary trader, it's a bit complicated thing. The second is gas price. I need to know which gas price should I set, and I don't want to overpay for gas costs as a user. So it's also complex for beginners. And there is a price impact. So if you trade some token that has not very good liquidity, then you will lose like tokens on the trade. Next, you have failed transactions. If market moves and you don't pass slippage tolerance, then your transaction just failed, you pay for nothing. You pay to miner for failed transaction. And also, as a user, I need to have native token on a balance to be able to send the transaction. So it's hard to attract new users to DeFi if we have such problems. This is how we came up with an idea of Fusion. So Fusion is intent-centric orders based on Doge auction that filled by professional market makers. And what we have, Fusion is gas-free. You don't need to pay for gas costs. Fusion protected from MEF attacks by design. And Fusion has limitless liquidity. Let's look at these things and figure out why it is. So, why Fusion is gasless? Fusion is simply a structure where you define the token pair and the amount that you would like to swap. And you sign this order and send to Relayer. So you don't need to send a transaction. You just make a signature of chain and send to the Relayer. Next, resolvers just catch this order and execute on behalf of the user. And the user pay for the transaction and the fees included in exchange rate, because resolvers should execute the transaction on behalf of the user and anyway pay for gas fees. But if I'm a user and I don't have either or other native currency on another blockchain, then it's okay if token supports permit standard, then I can just send the transaction with zero ether on a balance. Next, how Fusion protected from the MEF attacks? As I said, Fusion based on Doge auction. That means that at the specific block, the price curve has the fixed price. There is no any formula, and at the moment the price is fixed. And only resolvers can be front-run, but they are professionals. They know how to protect themselves. And they can be front-run, but only for their profit. For the user, at the specific block, the price is fixed, like in limit orders. And what about liquidity? With aggregators, we need to trust that the aggregator integrate all possible liquidity sources into their algorithm. But anyway, it's almost impossible because there are different market makers, small, big, anyway. And what is Fusion? Fusion is intent-based. You just submit some action that I want to swap, and for me it doesn't matter how this swap will happen. And we have resolvers who connected to the network, and they can execute orders like arbitraging with the centralized exchanges liquidity. They can arbitrage any DEXs. They can even match to Fusion orders between each other. Yeah, this is cool. And even maybe a cross-chain liquidity can be involved in this process. It's up to resolver. So we have limitless liquidity. And let's see how Fusion works in total. Me, as the maker, first of all, need to give an approval or permit to 1-inch router contract. Then I just sign and send the transaction to Relayer. And resolvers subscribed for the new orders. And each time when the resolver see that, oh, this price is good for me, I can execute it, then the resolver just submit the transaction into the network. That's it. So simple. And regarding the Doge auction, what is it and what defined by the Doge auction? The Doge auction, it's kind of a curve that has the duration. You can set any duration of your order when the price will be slightly decreased from the highest price to the minimal acceptable price. The second parameter is minimal return. This, in case of market movements, how much you are okay to receive. And also initial rate bump. This is the difference between start return amount and min return. And also our Doge curve customized with the additional points. Like these points change the price speed between two different points. Let's see what is it. And even Fusion price curve can improve the market price. For example, either costs 2000 USDT, but I swap the large amount and I can even improve the price. Let's see how it happens. So on the screen, you can see the real order that happened on chain. Some DeFi traders swapped more than 5,000 Ether to USDC, and he received 40K more compared to the market price when the order was placed. And how it works? We take into account the market liquidity. We try to split, like to find the price for the smallest amount to disable price impact. And we add additional points on this curve to improve the price at the beginning. So we start from the spot price, we go to the market price, 2/3 of the auction time. And in the end, in case of in case of market movements, your order can be executed by minimal return or not executed at all. So in this case, you pay nothing if order hasn't been executed because you haven't sent any transaction. You don't have failed transaction. And in this case, there was about 11 partial fills by the resolvers. And even it happened like about 3 or 4 resolvers submit their partial fills in parallel within the single block. And you can see that when auction just started, some resolver filled 10% of the order. And in one block, in 12 seconds, some other resolvers filled 30%. And this is how the user received more than he expected by the market price. Because when you swap small amount of the order, arbitrageurs come to the market, see that the market is imbalance, and swap back and balance the liquidity. Price goes back, resolver fill one more time, etc. Repeat, repeat, repeat. Yeah. So what we can build with the Fusion? It's up to you hackers, but we have 1-inch developer portal that we released recently, and you can take an advantage of different APIs, including Fusion API, Swap API, balances, token prices, etc. So you just need to go to portal.oneinch.dev, log in with your GitHub account, get an API key, and you can go through the docs and learn more. So, like what you can build with this. The spot price, like if you want to place the fiat price, the fiat representation of the token on UTXO, you can use spot price API. If you want to scan balances of different wallets, you can use balances API. If you want to get an access to more than 6 million tokens and sheet tokens, you can use tokens API and search not only using address, but even by symbol or name. And all tokens sorted by the rating, so you will never lose the right token. By these QR codes, you can search how to create fusion orders, how to connect to the dev portal, and how to become a resolver if you are a professional market maker. On the hackathon, we have 4 bounties. The first is about the fusion, just build a cool project that makes sense on top of the fusion engine. The second is about ERC20, the second is about token plugins. It's an ERC20 based extensions that allows to extend the functionality of tokenized assets. And actually regarding the dev portal, we would like to see some interesting use cases made by that uses the 1-inch developer portal APIs. And the last is OpenTrack. Yeah, that's it. Thank you. If you have any questions, feel free to ask me. Yep.
So can we run fusion orders from a smart contract?
So the question is, can we use a limit order from the smart contract? The answer, yes, totally. So the fusion orders, they based on 1-inch limit order protocol, and there is a standard that said that if the maker of the fusion order is smart contract, then in time of execution, we validate not the signature EDCA, you validate, you call isValid signature function on the maker address. And this function should returns the selector of selector of this function, or in case if something not okay for you, then this function throw an error or just return some random bytes. Yes, it's possible to use, but you need to implement on your maker address on the smart contract isValid signature function that has 2 arguments. It's a hash of the order and some arbitrary data that you provide for validation. Any other questions? Yeah, we have a booth. You can come, ask questions, and during the hackathon. Okay, thank you.
Summer nights and many hours since you left. Different ways, your voice still popping in my chest, and I still hope. I hope you're coming back soon. You're coming back soon. Take me to another place where the fairy tales don't end. Magical, magical land, magical, magical land. To another place where the fairy tales don't end. Magical, magical land, magical, magical land, magical, magical land. Magical, magical land. Magical, magical land. can stand that you ain't here with me. My life's a mess, all because of you. Need you now to be right beside me. 7 days and 20 hours since you left. Different ways, your voice still popping in my chest. And I still hope, I hope you're coming back soon. You're coming back soon. Take me to another place where the fairy tales don't end. Magical, magical land, magical, magical land. To another place where the fairy tales don't end. Magical, magical land, magical, magical land, magical, magical land. Magical, magical land. Magical, magical land.
When I found you in the wreckage of that ship, I considered leaving you. I was afraid you could bring trouble to us. What do you think they want?
Take me to another place where the fairy tales don't end. Magical, magical land, magical, magical land. To another place where the fairy tales don't end. Magical, magical land, magical, magical land, magical, magical land. Magical, magical land. Magical, magical land.
In my mind, in my head, this is where we all came from. The dreams we had, the love we shared, this is what we're waiting for. In my mind, in my head, this is where we all came from. In my mind, in my head, this is where we all came from. In my mind, in my head, this is where we all came from. The dreams we had, the love we shared, this is what we're waiting for. In my mind, in my head, this is where we all came from. In my mind, in my head, this is where we all came from. In my mind, in my mind, in my head, this is where we all came from. The dreams we had, the love we shared, this is what we're waiting for. In my mind, in my head, this is where we all came from. In my mind, in my head, this is where we all came from. got so far, but in the end, it doesn't even matter. I had to fall to lose it all. In the end, it doesn't even matter. I tried so hard and got so far, but in the end, it doesn't even matter. I had to fall to lose it all. In the end, it doesn't even matter. I tried so hard and got so far, but in the end, it doesn't even matter. I had to fall to lose it all. In the end, it doesn't even matter.
Üç, dört. Bugüne kadar size Atatürk'ün sevdiği şarkıları icra etmeye çalıştık. Şimdi karşınızda
Hayatta musiki lazım değildir. Çünkü hayat musikidir. Mustafa Kemal Atatürk'ün bu sözü beni daima çok etkilemiştir. Tarihte Atatürk dışında bir başka lider tanımıyorum ki müzikle bu kadar içli dışlı olsun, müziğe bu kadar önem versin, üzerine düşünsün.
İşte düşünsene ya, ülke kurmuşlar, meclis kurmuşlar, baştan bir sürü şey geçmiş, savaşlar atlatılmış, ölümden dönülmüş. Ondan sonra bir akşam bir yerdesin, işte yemeğini yiyorsun, bir şeyler içiyorsun, bir müzik dinliyorsun yani. Aslında hepimizin insan olduğunu hissettiren bir an yani benim için.
Başka devlet adamları için böyle bir kavramı hiç duymadık. Hani Napolyon'un sevdiği şarkılar. Kimsenin haberi bile yok. Atatürk'ün sevdiği şarkılar diye bir şey var gerçekten. Yani Atatürk'ün bizim için yeri o kadar farklı ki bunu biz düşünüyoruz.
Duygusal Atatürk'le bağ kurabileceğimi düşündüğüm bir proje olduğu için çok heyecanlandım.
Şimdi derdimiz aslında Atatürk'ün günümüzde yaşasa hangi şarkıları seveceğini bulmak.
Barış Manço'yu seveceğini tahmin ediyorum. Hem yerel hem batı filan yani böyle.
Anadolu rock olabilir.
Mesela Ajda Pekkan'ı dinleyebilirdi.
Yani evet, bir tür aşık geleneği gibi bir şey değil mi yani?
Tabii sadece kulak Atatürk'ün